Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So lately we've been programming in JavaScript, and the reason is because that's the programming language of the future, as you can notice. Like, you don't even need C anymore, right? So you can do everything in JavaScript these days. You may say that, like, how do you work with binary data and stuff like that? Well, you can work with binary data in JavaScript. Did you know that? Did you actually know that? Like, you can do binary data and stuff like that. So in JavaScript, as far as I know, so let's actually go somewhere in here. Like, I'm gonna open some files, let's say like whatever TypeScript file that I have in here, right? So ignore the code, doesn't really matter. So there's a thing here called array buffer, right? So there's a thing here called array buffer, and if you take a look at this thing, it represents a raw buffer of binary data, which is used to store data for the different typed arrays. And what are typed arrays? So you have things like uint8 array. So you can have arrays of bytes. People have misconceptions that JavaScript is this toy scripting language that only has floats and stuff like that. But no, you can have an array of uint bytes, right? uint8, like just like in C. You don't need C. You literally don't need, like, you have everything in JavaScript. Look at that. So then, but what about 32 bits? Like, you can have uint32 array. Okay, look at that. So this is just like, 32-bit integers. Like, what about floats? You can store floats. Right, something like this. So, and there's a very interesting thing. So if array buffer is sort of like a buffer, right, where you actually store some bytes, you can actually view those bytes in different ways. And as far as I know, like uint8 arrays and u32 are basically different views on those arrays. And there is another cool abstraction in JavaScript. As far as I know, it's called data view. Right, so it is called data view. And so it allows you to read different types like float 32, float 64 at different offsets and even different endianness. Yes, C developers, web devs are aware of endianness. What is endianness? What is little endian and big endian? We don't need your low-level languages. We have everything in our browser. I'm so sorry. Just can't help myself. But anyway, so yeah, so you can work with binary data and stuff like that. And like, why the fuck do I need to even work with binary data in this toy scripting language? Well, we're making a game, right? So we're making an online game, by the way, right? So let's actually run it. So I'm gonna do surf, right? I think I already compiled everything. So yeah, so this is the thing that we're developing, and look at that. This is just a prototype, right? This is just a prototype just to test the idea of how we're gonna be doing multiplayer stuff. So, and essentially, you can open this website in a different tab, and that automatically creates the second player. You can't really see that because of my stupid camera and stuff like that, but here is the second player, right? So you can control the player in here, right? So I have a focus in here, and as you can see, it all gets synchronized perfectly between two tabs, right? It gets synchronized and stuff like that. And how many tabs you open, this is how many players you're going to have. Right, so I can open another one, and there will be a third player in here. You can't really see it, but it's like down there, right? So now we have 3 of them. So yeah, that's pretty cool. That's pretty cool. But the way it works, it sends JSON messages, JSON objects over a WebSocket. And in fact, I have a feeling that it's a little bit wasteful. It's a tiny bit wasteful, right? So we can even try to estimate how wasteful it is. So essentially here I have a server running, and it prints statistics every, like, I think second or so, right? So it prints different statistics about how many messages were sent, like total, and then per tick, and how much time we take to process the tick and stuff like that. So let's actually open this entire game. Right, so we have 1 player right now, and I have a simple benchmark in here that allows me to spawn a bunch of bots, right, to sort of stress test this entire thing. So let's actually see how many bots I want to, okay, so we have 30 of them. Let's actually run 30 bots, right? So I'm starting the bots, and that basically created a bunch of bots, as you can see. So they're just moving around and stuff like that. So it's basically, it connects, makes n connections, actually 30 connections, and just like creates players and move around. So then we can take a look at the statistics of the server, and look what is happening, right? So it sends for 30 players, right? So it sends like around 60, like 70 messages per tick, right? It receives like 2 or 3 messages per tick from all of these players, 2 or 3 per tick. But then it sends like a lot of data, and in terms of bytes, it sends like 6 kilobytes. Like the more players you have, the more data it will send out. And all of that is because the messages we send and receive are literal JSONs. And another thing in here is that JSON, like you need to parse JSON. You actually need to parse JSON. And as you parse the JSON, it also, it's really difficult to create a JSON parser that is memory efficient, right? So because it's a tree, right? So it's like all over the place in memory, and it's generally like slow and stuff like that. It would be better if we used like very efficient, very lean binary protocol instead of JSON, especially when we're talking about real-time game, right? So it's better to actually send very small, very lean, like binary messages, right? So, and this is what I want to do today, right? This is what I want to do today. Instantly, some web devs in the chat, oh, protobufs, like, have you seen protobuf? Like, it's a huge fucking dependency for something that you can code yourself if you're not afraid of bytes. Looks like somebody's afraid of bytes. Look at them. They're afraid of bytes. They're afraid of bytes. We are real software developers. We're not afraid of bytes. We're not afraid to allocate our own array buffer. We're not afraid to actually slap data view on it and set float 32 and get float 32. We're not afraid of that. Get out with your protobuf. I'm joking. So, like again, we're not our protocol. In all seriousness, right? So, jokes aside, I'm joking, by the way. So, in all seriousness, protobuf is kind of a huge of a dependency for what we're about to do. Our protocol has like, how many messages? I think it has 2 or 3 messages. So first you have a greeting message. It's the message that is sent by the server to the client when you join in. So, and it just contains the state of the player. Then you have player joined event. It's when somebody joins, we notify all of the players that somebody joined. And we also have a sync message that synchronizes the state of the player. So we have 3 messages. And like, we don't need an entire protobuf just to serialize those 3 simple messages. We can do that ourselves manually. Like it's no big deal. Like this is something that C developers do all the time without any protobufs, because again, they are not afraid of bytes. Okay. Don't be afraid of bytes. This is why, by the way, all of the modern software is fucking bloated shit, because modern webs are just afraid of small, silly little bytes. They're just afraid of them. So that's I found the root cause of the problem. I'm afraid of being beaten with bytes. Okay. Anyways, so yeah, let's go ahead and try to fucking do that, mates. Let's go ahead and try to fucking do that. Like, I never really worked with binary protocols, WebSockets, and Scheiße like that. So I'm really curious what's going to happen if, for example, on the server, I will just send some binary Scheiße into the player, right? So let me see. So we have this kind of thing. So what I want to do, actually, I want to do run watch mode. So basically, I'm going to be starting TypeScript in watch mode. So we're going to continuously recompile this entire stuff. Right, I'm gonna start the server. I don't think I'm gonna start the server. So, all right, so we have two components in the entire system, right? So we have a server component, right? So which just creates a WebSocket server, and then we have a client which runs in the browser and connects to the WebSocket server. Let's go to the server and let's find where we're connecting. Okay, so here it is. Here's what we're doing. So this is basically an event when a client connects. You know what I want to do? You know what I want to do? I want to actually create array buffer in here, right? So let's create array buffer. And how do you construct an array buffer? So I think they have a separate constructor for that. Yeah, okay, so array buffer constructor, and you supply the length and stuff like that. Okay, so let's actually send maybe 4 bytes. You insert 4 bytes, right? So I'm gonna allocate the buffer in here. So this is gonna be our buffer. So, and I suppose, like I also need data view, right? So let's actually wrap that stuff with data view right away. So is it even compatible with it? Okay, so here, as you can see, it accepts the buffer, which is buffer-like, and also it intersects with bytes per element having type never. So it means it doesn't have that thing, or maybe I don't know. So what is an array buffer like? Array buffer like, it's one of the it's a, okay. It's basically array buffer or something that can be converted to array buffer or something like that. So anyway, what can I do? Can I just set uint? Yeah, uint 32. Here I can specify the byte offset, so let's actually say that we're going to be doing that at byte offset 0. So you can think of byte offsets as pointers. Wait a second. You can have pointers in JavaScript? Oh, sorry, but I mean the pointer is just a number, isn't it? Yeah, it's just an address in the memory. It is simply an address in the memory. And I can already hear all of the nerds screaming, no, it's actually not an address in memory. What about the point of provenance? Okay. But thinking about them as an address in memory is a good abstraction, okay? I do understand that the reality is a little bit more complicated, but I mean, it's a good abstraction. This is literally the reason why pointers exist, because you need to have an additional information within an address, but you still want to think about this kind of stuff as an address, and thus we created an abstraction. So that's kind of the point. That's kind of the point. You get what I'm saying? You get what I'm saying? Stop being nerd, okay? Stop being nerd. Okay, so says the guy that looks like a nerd, but anyway. So and here what we're gonna have in here? So we're gonna have a value. So let's actually do 69 for 20. And what's interesting is that little endian is an optional value all of a sudden. So if false or undefined, big endian. Isn't the majority machines on planet Earth right now are little endian? Or am I missing something? Wait. Like, am I missing something? Is the majority of machines on planet Earth right now are little endian? Oh, network byte order. Okay, so all right. So okay, so I'm gonna say explicitly little endian, right? So we're gonna be using little endian. Is a network? Yeah, I forgot that network communication is big endian, right? I completely forgot about that. You see, I'm not a network engineer. I'm just not a network engineer, so. All right, so we set some stuff in here, and I suppose the only thing I want to do in here is just to send this entire shit to the player, and maybe just close the circuit right away and just like return, right? So I just want to test some things, right? So I just want to test something. So obviously that breaks the game, but that's fine. We're totally fine with that. We're here to break shit. So when I send things, I can send things like buffer-like, and here are all of the things that I can send in here, and that in fact includes array buffer. Okay, so that's pretty cool. Let me now open this entire thing, and it doesn't even open because we don't really have the server. So let's actually serve this entire thing. let's actually surf. So let me open this entire stuff, and it is disconnected, obviously, right? So because we just sent something that the client didn't expect, but hopefully it actually logged. Okay, look at that. So object. This is the most JavaScript error message ever. Only JavaScript can throw this kind of message. Like, yeah. Anyways. Right, so let's actually go into the client. Client MTS. Right, so where do we accept the messages? Where do we accept the messages? Yeah, so essentially I just did parse. So yeah, it converted this thing to a string and then passed it to JSON parse, and now we verify this is a correct message and stuff like that, so everything's fine. So let me try to do the following thing. I'm going to try to do console event data, and then I'm going to just right away you know, return out of that. So we're currently on the client. So let me refresh this entire thing, and we got a blob. Look at that. We get a motherfucking blob with 4 bytes. It's bytes. It's bytes. It's bytes. So we have array buffer. How can I take the bytes out of the motherfucking blob? How can I even take that? So if I take a look at the data, oh, it's T. So returns data of the message, and T is any. That is sus. So it doesn't even specify in TypeScript typings that like what kind of thing it could be. Like it doesn't even specify what kind of thing it could be. Right, so data property value sent by message. This can be any data type depending on what originated this event. These fucking web devs don't even know themselves. It's just, yeah, it's whatever. It's just like it will send you something. No fucking wonder all of these web applications are so goddamn fucking broken, because these web devs don't even know what goes where. They don't even fucking, well, it's just will give you something. It depends. It's just like what server sent. I don't fucking know. Oh, I'm a web dev. Okay. So it's about, we can assume that this is basically like a blob, right? So it's going to be a blob. Right. Flip-flop glazing JS to hating JS duality of this man. This is the point, because it doesn't fucking matter. All of your tech tribalism is bullshit, and none of that it fucking matters. Right. Your job as a software engineer is to fucking solve the problems, regardless of the language, regardless of the stack. Right. And they flip-flop between these two things to show you how stupid it all is. It's fucking stupid. Your job as a software engineer is to solve fucking problems. That's what it is. Right, and programming is programming. Right, so like an actual professional programmer should not be afraid of C. They should not be afraid of JavaScript. They should not be afraid of Java. They should not be afraid of Haskell. They should not be afraid of C#. That's what being software engineer is. This hyper-specialization, I think, like I have a hypothesis, it's basically to create more bullshit job in Silicon Valley, I think, right? So, like, I don't know why people so hyper fucking specializing, right? On web dev. I'm a web dev now. What's next? Let's hyper specialize even more. I'm a if else statements dev, right? Like, I don't know for loops. I never studied them in university. We only studied if else. I'm a senior if else engineer. Like, it's fucking stupid. It's fucking stupid. That's what it is. I'm a reject step. Anyway, so let's continue. And I literally don't care about JavaScript, neither do I care about C, and neither do I care which language is the best. I'm just making fun of these tribalist people. Like, I'm just making fun of all of them. That's me making fun of all of that. Right? And you know what, when it gets funnier? when people get tricked into thinking that I'm in the opposite tribe. Oh, he's a fucking JavaScript hater. Oh, I'm gonna defend JavaScript right now. I'm gonna defend JavaScript. It's just like so fucking funny. It's just like, holy shit. Like, I don't give a shit. It's, yeah, defending brand. It's almost like defending brand. It does feel like defending brands, honestly. It does feel like it. All right. So let me see. So we've got some data. How can I do the blob scheiße? So we have array buffer. Promise. You fucking serious? Well, I mean, it kind of makes sense, I suppose. If the blob is big, you want to do that asynchronously, I suppose. But I mean, you still receive it as a one single thing at a time, and when you receive a string, you don't have a... This is bizarre, my friend. Right, that is bizarre. But anyway, so what I want to do, I want to actually try to do something like type of, right? So I just want to see if I can, you know, distinguish between different kinds of messages by type of, right? So let's actually see. Ah, fuck, it's object. I was hoping that it's going to be something like blob. So it's probably some sort of a class. So I probably can do something like an instance of blob. All right, so instance of, okay, so this is true. So this is basically what we can use in here. Right, so we can even do some stuff like if this thing is a blob, right, we handle it in a certain way. If it's something else, if it's a string, we handle it in a different way. So, and that's, I suppose, how the developers expected us to handle this data, right? So depending on what you receive from the server, right, depending on what you receive from the server, you're gonna just do if instance of that or if type of that, and so on and so on and so forth, right? So that's how it was expected to work, I think. Anyway, so data array buffer. So we're taking the array buffer, and I suppose this thing has to be the asynchronous thing, and it has to be await, all right? So, and then we're gonna just take the buffer. There we go. So we got the buffer. So then I'm gonna just bring this entire thing. So let's go. So yeah, there we go. We've got array buffer, and do we have the bytes? I think we can interpret this thing as, yeah, look at that. Look at that. So 44, 15, and 1. We can try to manually recover that. Can we try to manually recover that? 44. So this is the least significant bytes, right? So that means 44 plus 15 multiplied by 255 and plus 1 multiplied by 255. Almost. Oh, actually 6. I think it has to be 6. Yeah, there we go. Look at that. Look at that. I'm not afraid of bytes. I can recover byte representation of you in 32. So, yes, I can do that. I'm not afraid of bytes. Unlike those web developers. Anyways. Now, right, so how can I do all of that? So can I construct something like a new data view, right? So this is going to be some sort of a data view. And can I now do view get uint32, right? So at a particular offset, right? So 0 true, and that is going to be the case. Can I even do something like that? I think I should be able to do it like that. There we go. Yeah, there we go. So we just sent 69,420 as a raw data over WebSocket. That's what we just did. And what's interesting is that we sent it as a 4 bytes. 69,420 takes 5 bytes. We saved 1 byte. We saved 1 byte. Can your JSON do that? All the JSON devs are in shambles right now. Fuck JSON. Anyways, JSON devs are inferior to C devs. Yes, it is C versus JSON. C is the future. JSON is out. Fucking out. So now we can set some binary data. So now we can actually try to pack like structures and send them like with bytes and stuff like that. So essentially how a hello message looks like. Let me see. So if we take a look at the interface, hello, right, we can just try to encode all of these fields in binary. So for example, for kind, we can allocate a single byte, right? We can try to do something like this. So let me see. So essentially we can say, okay, kind is going to be uint8. So it's going to be 1 byte. So you receive some sort of a blob, right? You receive some sort of a blob. You look at the first byte of the blob. And then, depending on the number in there, you know what kind of structure it is, right? What's interesting is that you may also have, you also know the size of the structure effectively, right? And as soon as you identify the kind of the structure, you can verify that the size of the structure is correct, right? So because this is the kind of information I expect to know. So afterwards, we have ID, and for ID of the player, I expect to maybe use uint32. I think that's a reasonable thing to use in here. So then we're gonna have another 4 bytes. Let's say it's gonna be float32, then another float32, and here we have a hue. I used to actually send a style, right, an entire CSS style. So this was a string, but then I changed it to a number, which is a hue in HSL, right? Hue, saturation, lightness, or luminance, or whatever the fuck it is, doesn't matter, right? Why I change it like that? Because on the client, I want to be able to modify the saturation and value of that color. So the idea is that, right, so the player is brighter and more saturated than the rest of the player, so it stands out. So one of the problems with this kind of demo we had is that the player doesn't really stand out, and it's very difficult to see yourself in a crowd. I can probably demonstrate that, so let's actually go ahead and do that. So hopefully that recompiled, and let's actually serve this entire thing. So maybe I can even start some bots, right? Run bots. Let me refresh this entire thing, and there we go. So as you can see, we have a lot of people in here, and what I do in here is just like I dim the rest of the bots a little bit, and I make the player a little bit more saturated, and also I put like a frame around them. So because of that, we only assign hue to the player, and saturation and luminance is something that is customizable depending on visualization and representation. So you know what I mean? You know what I mean? So now it is a number which is a value from 0 to 360, right? And yeah, so, and that is, since it's a value from 0 to 260, I think we can allocate a single byte to that. I know that 360 is more than a single byte, but we can actually normalize it to just value from 0 to 255, right? So we can take a range from 0 to 360 and map it to a range to 0 to 255, right? Not a big deal. We're gonna probably lose a little bit of a precision, but I don't think the human eye is going to notice that much, and I don't think even if they notice that, it's not gonna matter that much either. So anyways, let's actually bring back this stuff in here, and let me revert this entire thing. There we go. So we're going to have a hue, which is a uint8. And what's interesting is that it's almost aligned, right? So this is 4 bytes, this is 4 bytes, this is 4 bytes. These two things together form 2 bytes. So to pad things around, we can even add something like a pad uint16 or something, but I don't think I'm going to do that, right? So, yeah, so it can be even aligned if we want to. So this is a single message, right? So this is a single message. And maybe we can even implement something like batching of the messages, right? So instead of like sending one message per time, in the future, we can actually have several of them, right? So they sort of like go continuously in memory. And the first thing that you have in here is more like a count, right? So which is a uint32. So we batch them up. And then how do you parse them? Right, so you look at the next byte after the 4 bytes of the count, right? You like identify the kind, parse this message, go to the next one, and since you know the count, you kind of know how many of them you can expect. Right, so we can think about whether each message has to have the same size in bytes, or they could be various, like the size can vary, but I don't think it matters that much right now, right? So we can think about that. But I think varying the size of the messages is not that critical, right? So it doesn't have to be like a super perfectly aligned, in my opinion, right? So at least for what we're trying to do, we're trying to reduce the amount of data. So, I know you won't need to, but what if you wanted to send a string? How would you do that? I suppose like it's, I mean, I don't know, size. It's a sized string. String bytes. We can employ some sort of way to encode different sizes. So essentially, for example, what if your string is very small and its size is 255? Right, so there are different ways to encode this sort of count. If the count is below 255, or actually like 127, we're using 1 bytes. If it's more than 127, we use 2 bytes, and there's different ways to encode it. So essentially, you can slowly grow the amount of memory you consume for the counter depending on the size of the counter. Like, I don't know any schemes off the top of my head, but I remember seeing some of them in WebSocket implementation. WebSocket, as far as I know, employs some of these things, I think. Right. Also, I remember seeing similar schemes in Beam virtual machine implementation. So there's a, there is options that I can pick from, right? So it's not particularly like a novel idea. A lot of people implemented it before, right? But I don't think I need it right now. So anyways, so we want to do something like this, and I wonder what can I do. So let me maybe grab this entire thing. I kind of want to go to the server. So let's go to the server MTS. And this is where we send in this Scheiße. What I'm thinking, chat, let's try. When you send in the message hello, where do we send the message hello? Right, so this is where we send in the message hello. Cool. Instead of sending that message, can we just send a binary version of hello? I think that's an interesting idea. So first of all, we can say that we have kind, right? So this is basically kind. Then here it is. We have ID, which is 4 bytes, right? So this is going to be ID. I think I want to bring this thing a little bit closer. And I don't want to use comma. It's actually plus. That's what I wanted to use. So then we're going to have X, which is, it's 4X. Y, and this is 1 hue, right? So this is 1 hue. There we go. So we're allocating the buffer, right? And now we need to basically set all of these values in here. Do you have enumerations in? It's still going, by the way. I probably need to kill it. Right. TypeScript, like enumerations, but number enumerations, right? So TypeScript, TypeScript in nums. There's some sort of enums. There should be some sort of enums. All right. So I hope it's not like, string based. Okay, so you can have enumerations. That's pretty cool. And I suppose the number based and stuff like that. So we can probably introduce something in here. For instance, we can do enum message kind. Right, so in here we can have hello for now, right? So we can have hello. I'm actually really curious, what does it get compiles to? What does it get compiled to? So let's take a look at MGS. And so did it compile to anything? So message kind, Jesus, bro. So this is what enumeration got compiled to. Let me take a look at the JS mod. So I suppose what it did, it created like a separate namespace, so you can just, yeah, you can just have this entire thing. Let me see if I put this stuff in here. Message kind is not defined. I suppose this is what you want to have, right? So yeah, there we go. So message kind. Ooh, that's very interesting. So you can do, so by knowing the value, you can take the name, and by knowing the name, you can, oh, okay. That's actually pretty cool. It's almost like C enumerations or something, right? I think it's like C enumerations, right? But that's fine. That's fine. So this is what we're gonna have. Can I? So they say that you can assign things in here, right? So does it get translated properly? Oh, look at this. It's actually 69. Look at that. Look at that. So okay, proper enumerations. Very, very cool. So now in the server, what I want to do, I want to set uint8 at offset 0, and the value I'm going to set in here is going to be message. I set message kind hello. Cool. So buffer set uint32, and it's actually at 1. So and the value is going to be, so this is ID. I have to take the joint player ID. So this is kind of an ass thing to do, and obviously I want to actually do a little ending. So can I employ the trick that I invented in You know what I'm talking about? You know what I'm talking about? The trick that I employed in Port. So essentially, the idea is have some sort of IOTA. So, and I employed that trick in Port, but I stole that from Go. So, and essentially, what I want to have, so I have IOTA, and then I say, okay, so I have kind of set, and kind of set is equal to IOTA, and then IOTA plus the size of the field, right? Okay, that's pretty cool. So the next field I have in here, ID field, so it's equal to IOTA plus the size of the field. So IOTA, I think it's pronounced like IOTA, but in Go, if you Google up IOTA, it's sort of like a special variable for defining enumerations, right? So you can read more about this thing in here. So I think, I'm not sure if it's a good example, but essentially, yeah, so there's a spec in here. So it's a pretty big spec. So within the constant declaration, the predeclared identifiers iota represents successive untyped integer constants, right? So essentially, look at that. You define C0, C1. I tried to increase the scale, and it actually is so goddamn fucking slow because it's a huge fucking page. Okay, look at that. So you just define this as a constant declaration. So you're defining a bunch of constants, right? So you define C0 equal iota, C1 equal iota, C2 equal iota. And it's kind of weird, like you define it as the same thing. But look at that. It gets incremented. So it's a variable that gets incremented at compile time, so you can define enumerations. Right, and you can even specify sort of like as this step with which you're incrementing and stuff like that, right? So it's basically that. I think I'm going to put that stuff in here, and for people on YouTube, I'm going to actually put that in the description, right? So, and I use a similar idea in Port, and it's actually really funny that you can use the same idea at runtime, right? So here I have iota. And I just like use its value and then increment it by the size of the field. So I sort of at runtime define a C structure. So that's what I'm doing here. I'm defining a C structure. Right. So in here we can do X offset. So this is going to be that. And what's funny is that you can go further and you can say something like uint8 size, which is 1, then uint32, which is 4, and then float 32, which is 4. And then you kind of define a field. So you define the offset of the field and the name of the field and its type. Right. You kind of like simulating definition of the C structures, actually. Right. That's kind of cool. So you can do something like that. Right. So you can have X, then Y, and then we're gonna have a hue, and the hue is gonna be just uint. And by the way, X and Y has to be actually float. It has to be actually float. Right. So this is the float. And what's fun is that now you can say that the size is equal to iota. Iota now contains size. It contains size now, right? So that means you can just do something like this. And you can change the order of the fields. You can change the order of the fields. Offsets like will be updated, and you can add more things in here, and the size is going to be updated. So this is basically a definition of a C structure in JavaScript. He's writing C in JS. That's exactly what I'm talking about. That's exactly what I'm talking about, people. Stop learning languages, start learning programming and how computers work. This is exactly what I'm talking about, bro. Sorry. But now I can just like use this motherfucking offsets, right, like that. And I don't have to worry about specific numbers and shit. Look at that. Look at that shit. Look at that shit. Look at that shit. Look at that. Okay, that's pretty cool. So now we can do some other things like a float 32. So this float 32 also works, right? So here's the offset, and this is X offset, and this is going to be basically X, right? So this is going to be Y, and this is Y, and this one is going to be uint. So the only problem that I see in here is that like you should be really careful with what methods you use on a data view, right? Because yeah, so we don't really know the type of these things. We don't really know the type of these things, so it's kind of dangerous to do it like that. But anyway, so here we send hello. Here we send hello, and that seems to be working. Does it even compile? Let's actually find out if it compiles or not. It does in fact compile. No, it doesn't compile because we have 10 errors and shit. Okay, so this is what we sending instead of like hello. And by the way, so let's actually not close anything. After we send the message, we can specify how many bytes we sent, right? So we know exactly how many bytes we sent, right? So because I think you even have like a byte length, right? You can do that. And message counters, in terms of the messages, we send only one message, right? So there we go. We can now remove this entire thing in here. So we kind of ported one JSON message to that. So this one has to be hewn. Yeah, whatever. All right. So let me think. Now let's try to run. Okay, so what's funny is that you don't need little endian for this thing because it's a single byte. Endianness only makes sense when you have several bytes. Okay, let's actually see how a client is going to react to that. So are you okay? Are you still yapping? It's taking some time because it's super hot right now. All right, so 260. Oh, I didn't save. Okay, so that's fine. So yeah, this thing is a player. Where was the socket through which we were sending stuff? So it was a joint player. Okay. So this one is a joint player. So we take WS and we just send things. Okay, that's cool. So now let me restart the server. Right, so we're starting the server, and what's the current client situation? So currently yeah, we're just receiving something and we just return it. So let's actually not do that. Let's actually not do that. Okay, let me now open this thing, and it fails as far as I can tell. Right, so it fails. Let's take a look at the DevTools. Yeah, so it cannot parse the blob, which is fine. Okay, so on the client, what do we have? We have two states, when me is undefined and when me is defined. Me is undefined when we connected, but the server hasn't greeted us yet. It hasn't sent the hello message where it contains the ID of us, our position and stuff like that. So, and I suppose when we're in that state, we right now expect JSON. What we have to expect instead is a blob. Right, so the thing I want to do in here is probably say, okay, if event data instance of blob, only then we're going to be doing all of that stuff in here. Right. If it's not a blob, so the only message that we handle in here is hello. So I suppose we're gonna expect only binary messages in here. And if the message is not binary, let's say that we received bogus amogus message from the server. Right. So expected binary data, something like this. Make sense? Makes sense. Okay. So we received bogus amogus. So, and in here, yes, so this is what we have, and we can start parsing this entire thing. Interestingly, like I want to have an access to all of these things in a client as well. So that means I need to move that definition to the common module. I wonder if I can collect this entire thing to an object, right? Because it's too many small little things. All right, and I wonder if I can just do something like const hello struct, right? So, and just like make it like that, if you know what I'm talking about. And I think I will be able to easily do it like that. I think I'll be able to easily do it like that. So this one is not particularly convenient. I wonder if I can like kind of wrap all of that into its own separate function, where I could have like iota and simply like return this object in here. And obviously then I want to call this function, so it's sort of like a block from which I can return things. So this one is not particularly convenient, so like I could do something like this. Maybe I can do like a lock size. Let's say this is going to be a function, so it's a lock size. And so we can say offset iota plus size return offset. So now can I just do something like this? So this is the size of this thing. And obviously we want to rename semicolons with comma. This comma. Know what I'm talking about, chat? You know what I'm talking about? Right, so it's just like, it's now like an object. It's now like an object. ID offset. No, it doesn't. How on earth this modifies iota? We need to modify iota. That does not modify it. We need to modify it and return its previous value. So no, the answer is no, it doesn't work like you think it does. Right, so something like this. And I suppose now we are going to do this kind of thing. So hello struct and hello struct. So that seems to be compiling. So in here we can say hello struct size. This is actually super convenient, right? So because the struct also kind of contains its own sizes. So what do you complain about in here? What do you complain about? Yeah, so this is okay, so that's cool, that's cool. Hello struct, hello struct, hello struct. Damn. So now I suppose one of the things we can do, we can even just move that shit to common, so we can share this shit between fucking stuff. So iota plus would work. I don't think it works because plus equals returns the new value, but I need to return the previous one. That's the problem in here. There is a reason why I first save offset, then increment and return the old value, because that's what I need to do. I need something an equivalent of post increment, but for plus equals. So it doesn't matter in the grand scheme of things because it's already solved problem. I already solved it. I already solved it. I already solved the chat. Calm down. Calm down. I already solved it. Okay, so what do we have in here? Let me export this entire thing. Let me export this entire thing. So, and in here, okay, can I just do something like a common, or do I have to do something else? Oh, it works. Okay, so that means I can do something like that. So common hello struct. Okay, so that's pretty cool. So I think I'm gonna even move this entire thing. Why suddenly no camel case? To dab on a camel case tribe. So now let me see. Okay, so now here's an important thing. We have an access to this scheisse. Real programmers are not afraid of snake case, exactly. We're not a soy devs in here. We're not a soy devs. So in here, right, so now we should be able to access those things from here, which is nice, which is nice. So this is the blob, and I can do event data array buffer, and this is going to be something like that. So this is the array buffer, and obviously I hated that it's... Wait, is it going to even work properly? So because it's gonna basically reschedule some stuff a little bit later. Damn, this is potentially bad. It may, like, the fact that it's asynchronous may fuck us up in the ass in the future. Like, can anybody explain me why when we send string it is synchronous API, but when we send binary data it is asynchronous one? What the fuck is... What? Like, who designed this API? Who the fuck designed this API? String safe, bytes unsafe. But I mean, making it asynchronous doesn't make it safe. Like, what is safe on the safe? Like, asynchronicity is actually kind of orthogonal problem to this. It's just like, it's a random ass fucking decision. Like, you know what? I need to make a break from web bullshit, right? So let's make a break from web bullshit, and I'm gonna refill my tea, and I'm gonna calm down. I'm gonna think about this kind of stuff, and yeah, let's make some break. Okay, so we get a buffer, so let's actually wrap it into a new data view. Right, so we have this kind of stuff, and the thing we can do in here, I think I'm going to just maybe even, yeah, so I'm still thinking whether I want to maybe comment out this entire thing. Do I want to comment out? I think I do want to comment out. Right, so we got the buffer, and then let's actually print it, right? So because I want to see what's inside of it. Do we even get anything useful out of that? and I'm gonna just return like so. So, all right, let me now try to run this over. So it complains about something, but I don't really know. Because it does not on type never. Okay, so it doesn't really matter. So it doesn't compile, but it still generates some stuff. So whatever, who cares? All right, let's go. So let's open this entire thing, and obviously it doesn't do anything. Let's open DevTools. Okay, so we got the data view, which is 14. So we have a byte array. And if we take a look at the bytes themselves, right, it's a uint array. Okay, so I suppose the ID here is 0. The kind is 0, message hello is 0, the ID is 0. And then here we already have the rest of the stuff. So if I refresh, the ID should be actually equal to 1, so because it should be incremented. It should be, yeah, there we go. As you can see, it's now 1. Kind is still 0, which is expected in here. Right, and we managed to encode an entire like a structure in these bytes in here. In these bytes. Right. In these bytes. Okay. These bytes. So now we can try to maybe parse that. So let's go ahead and do that. So buffer get uint8. You get uint8, and so you have to specify the offset common hello struct, and this is going to be the kind of set. And I suppose we want to do console log. So this is the kind. So let me refresh. Okay, kind is 0, as you can see. Kind is 0. So what about the ID? Get uint32. So this is ID offset. This is ID. This doesn't look correct. Is that because it probably has something to do with the endianness, endianness Jones. So we have to put true in here, and okay, so now it's 5, right? So that is reasonable now. I can see that it is in fact reasonable. All right, so the next one is going to be x, but this time it's going to be float 32, right? So and it's going to be x y, right? So this is y, and hue. By the way, we have to be a little bit careful with the hue, all right, because it's a value from 360, if I'm not mistaken, right? So let me see how we're generating a new hue. All right, so it's player, other player hue. Yeah, so it's a random value from 0 to 360. So that means when we're greeting the player, where is the hello? So hello struct. So as you can see, here is the hue. We have to normalize it to a value from 0 to 1. So that means we have to divide it by 360. And then let's multiply it by 256. Right, since when we're generating the hue, we're using random, and random does not include 0, it is never equal to 360. It is never equal to 360. So because of that, this thing is never going to be equal to 256. Right, and it probably makes sense to maybe floor it just in case to get rid of the fractional part. Right, so that makes sense, I suppose. That makes sense. So now the next thing. So when we receive the offset, we'll probably need to convert it back into the 360 range, but we don't really need that right now. We're gonna do that a little bit later. So okay, let's try to go ahead and just like rerun, and yeah, that seems to be working. So X and Y look reasonable. They are within the size of the world and stuff like that. I don't see hue though. Where's hue? So offset outside of the bounds of data. Ooh. You int. This is dangerous, bro. This is dangerous. So you see, I can easily make a mistake. JavaScript segfault. It again, I'm fucking telling you, you don't need C in the year of our Lord 2024. Like, you just don't fucking need it. You want to have segfolds? You can have segfolds in JavaScript. So there you go. So, so I think the information about what method has to be used in here, you could represent a byte backwards. Maybe you could. The information about what method we have to use in here has to be part of the definition of this field, sort of speak, if you know what I'm talking about. I think it has to be the definition, part of the definition. Because I can see myself making this kind of mistakes over and over again, and yep. So let me see. So maybe we should fall into intellectual masturbation mode. Right, some sort of intellectual masturbation mode. What if we, like, instead of just offsets, each individual thing in here was more like a structure? Alright, so something like interface field. Right, and in here you have an offset, which is a number. Maybe size or something like size of this field. And also, yeah, methods that read and write. We can even say that maybe it's something like, okay, so you read that field, you read it from the view, right? You have to supply the view from which you're reading that. And maybe you also have to supply the offset of the structure, right? So like from where you're reading all of that. So this is sort of like the base point, right? And it will give you essentially the number, right? So can you do that like that? So let me enable fly check mode. Right, so if I put garbage in here, it will complain about, yeah, it complains about garbage. If I don't put, okay, so that is a valid syntax. That is a valid syntax. So, and in here, when I write something, I provide view, offset, and a value that I want to write in there. And here, I don't even have to do anything here. So what you're complaining about? Which lacks return type annotation. Really? Like, what if I don't return anything? Is that literally void? It's literally void. Okay. Okay. So and in here, what we can do, we can just say, okay, so if it's going to be a field, so this is the offset of the field. All right, so, and in here, the size of the field is going to be that. I'm not sure if size is really that useful, but there you go. And a read is going to be, I suppose, a function that accepts the view. Right, so can I even, probably can't specify that. View and offset. All right, so view and offset. I want to be able to actually grab this specific offset, so that means I need to have access to this somehow, so I can do this offset. It doesn't even return to that. I wonder if I can factor this entire shit out to something like alloc field, right? So let me see, function alloc uint 8 field, right? So let's put that, all of that shit in here, whatever, doesn't matter. And it's going to return the field, but it's going to, fuck, it needs to, yeah, it needs an access to the alloc function. Right, it needs an access to the alloc function because it's going to be incrementing the iota. It's going to be incrementing the iota. That kind of sucks, mate. That kind of sucks, but anyway. So this is something that we're going to be returning here, obviously. We can try to maybe pass that function in there. But that means, like, where do we keep that implementation? And this function needs to have an access to the state. So this thing has to be sort of like its own entity, which is an allocator. Yeah, pass an allocator. I'm getting to a conclusion that I need an allocator, but it's not a really like dynamic memory allocator. It's more like a static memory allocator just to define the. Can't you just pre-calculate all of? What do you think I'm doing right now? What do you think I'm doing? I'm literally pre-calculating the offsets. I'm sorry, I need to calm down. By pure how? You mean manually? Well, I mean, we kind of came to the conclusion that we don't want to do that manually. I misunderstood. It's fine, right? Whatever. it was just kind of funny, right? That's literally what I'm doing. Right? It's just like, can you just do the thing that you're doing? So yeah, yeah. Next stream implementing garbage collector for the allocator in JS. Exactly. Who needs C? Who needs C? Nobody fucking needs C. So I think you can do some shit. I think I remember seeing this kind of stuff specifically in the definition of like send of socket. You can define structures without giving them specific names. I can say an allocator number, so I actually call it iota, right? Something like this. Allocator, right? And that's about it, honestly. Then within the alloc uint field, I can do basically const offset equal allocator iota, right? And then allocator iota plus uint 8 size. Right. So here is the offset, here is the size. Might as well maybe even do something like this. So this is the size. And when I do the read, I can do view get. So there is a difference between, so this is a base offset, right? So it's called base offset. Get uint 8 base offset plus the field offset, right? So base offset plus the field offset, and yeah, that's about it. So it doesn't like so we have to why are you I don't understand what's the error. I didn't see it. Void. I didn't really say that it's a void. We have to return this entire thing. Yeah, there we go. Yeah, boy. And then I can do write. So here, when I do write, so this is base offset and this is a value. I think that's how you do that. Right, so let's actually indicate that this is just the base offset. Base. This is a base. Base. Base offset plus offset, and we're just writing the value. I wonder if I can do some scheiße like this, right? Because with the fat arrow lambdas, if it's, yeah, you can do it like that, right? So it returns. All right, so that means I can do it even like that. Look at this compactness, bro. Look at this compactness. Yo. What's interesting is that this is how you pass primitive values in JavaScript by reference, by wrapping them in an object. That's how we do that. That's literally how we do that. So in here I can say probably alloc uint field. Do we have to pass anything? So, and then I have to pass the allocator. And the allocator is just something like allocator equal to iota, like so. Right, I suppose I have to now do that for all of the types in here. All right, so let's just copy paste. Who needs templates, brother? So uint 32, so this is going to be 32, and this one, by the way, this is a size 32. and this one is the size. Right, so this is 32, and now this one is really interesting, right? So it's 32, but in here, I think we have to also specify the little endian, right? So by default, so we're always going to be using little endian, alloc uint 32 field, and here this is just an allocator. I said allocator. There we go. Okay. So, and the only thing that is left in here is uint 32 float 32, except in here float 32. Look at that. Look at that. Maybe we can do that. So I think we're gonna eventually create our own protobuf, not filed. Emacs, okay. Uint 8, and the size here is obviously going to be just the allocator. Allocator iota. Huh. Okay, it seems to be compiled. It seems to be compiled. So what is this? So it's somewhere on the client, doesn't really matter that much. Hue uint, did I? Oh, okay, so it has to be uint, that's right. So it's uint 8. So, and by the way, I think since this thing is like field, an entire like field definition, we should not say it's an offset, right? It's just its own field. Yeah. I feel like we don't really need the size in here, but I mean, that's fine. Totally fine. Okay, so let me now go to the server and let's see how many problems we... Yeah, there we go. So yeah, I'm doing this set in here, but now I don't even have to do that. So what I do instead is a common hello struct. I take the kind and I write. So where do I write? I write into the buffer. So I think I should call it view, right, for the consistency, because the parameter is called view. The base of sets in our case is 0, right? So, and I think I need the base of set in case I have an array of these structs, right? You know what I'm talking about, like an array of these structs. So then I can specify where exactly I want to do these things. So write, and so what does it say? Data of set, and the value that I'm writing in here is this one. And that's it. Yeah, that's pretty cool. To be fair, like, okay, so let's actually not do the camel case in here. Right, so let's be consistent. Let's use snake case. Let's use camel case everywhere. That way, it kind of makes sense. It actually kind of looks good. Look at that. So you kind of define a structure, and then you say, okay, so here's the field. So write that value for that field. Right? It's kind of cool. It's like using C, right? So basically we are reinventing C within JavaScript. Right. So this is the size. Okay. Can I do a little bit of an Emacs magic? I wonder if I can do a little bit of an Emacs magic by just grabbing this entire thing, maybe even, you know what, deleting this stuff and then doing something like that, then deleting that stuff, then doing write view 0, and that's about it actually. So the only thing we don't need in here is true. Right, look at that. So then we're sending the view, right, and this is how many. Damn, look at that sexy code. Look at that sexy code. Ooh. That's pretty cool. That's pretty cool. You can probably even go write some code that accepts the struct definition and JavaScript object and spits out the data view or array buffer for you automatically. So but order of writing matters. No, it shouldn't, because it's based on the offset. So let me now see what we have. All right, so within the client, yeah. So now I don't even have to do this kind of stuff anymore, right? So let me just, oh yeah, I put space in here. Now what should I be able to do? We can remove that. This is not an offset anymore. And we can just say, okay, I'm reading the value from this place. Why are you so wacky, brother? What? Oh, okay, I see. Because this is because of this extra thing. All right. So, and because of that extra thing. So also we don't need true in here. True is kind of redundant. So in terms of read. Oh, it also needs to accept the view. Okay, so let's quickly do that. So this is view, right? This is view. And then I can just do view, boom. Right, it's a compile, doesn't fucking, but I mean, it's fine, it's fine. So let me refresh, Everything seems to be working. Okay, so yeah, so we have a better definition for the structures now. So we have a better definition for the structures now. So what I'm thinking is that now, what I have to do, I have to check that the kind is the hello message, right? So this is what I can do in here. I can grab the kind. And is it equal to the message, actually common message type hello? Is it hello? Right. It's not visible in the common, so I exported it. So can I just like not do that? Okay, it seems to be, so maybe I just don't have flight check mode. Yeah. So what you don't like in here? Type import, so it has to be part of the type import. So the bizarre thing in here is that, all right, what if I remove this stuff? Flight check next error. Yeah. So let's do message type. Let's do message type next error and bro. It's imported using type. Are you for real? So you can, okay, so I thought it is a type, but now it does not. Really? Like, am I going crazy again? Message kind, oh my god, Jesus Christ. Okay, so I probably need to make another break soon. All right, so let's do it like that. So this is going to be ID. And right, so if this is not the correct kind, we probably have to say that this is a bogus amogus message, right? So that's very important. We can even go as far as checking the size of the structure and making sure that it is equal to the expected one. For instance, we can say, okay, common hello struct size equal, right, so there's this kind of equal in here, equal to the view byte length, right, view byte length. So that's what we have in here. So we make sure, we can even first check that the size of the structure is correct, right, and then the first byte contains that. So because what if it's equal to 0? So that means there is no byte, so we have segfault. Right, so we have segfault. Now let me see. So this is ID, And yeah, so now we can start actually filling up these things. So this is going to be X, and we're reading X. It's going to be Y, we're reading Y. And here is the hue. Here comes the hue. And in here we have to divide it by 256 and multiply by 360, right? So we have to convert all of that stuff back. And on top of that, we also need to have the moving. Right. Let's go, bro, let's go. All right, so I think that's about it. So it complains about something here, so but we don't have the message. Bogus Amogus message from the server, so let's actually just put view in here and remove that. So we migrated one message to binary. So so this is basically incorrect hello message, something like that, right? So we don't need to do that anymore, right? So hello struct is the same size as we expect in here, and so the kind is equal to that, and there we go, we deserialize this entire thing. All right, so we deserialize it, and it seems to be compiled as well. All right, so let's refresh it, and there we go. So it works, but then it disconnected. So received bogus Amogus message from the server. We do not know anything about the player with ID 10. Did I not fully do something? I think I forgot to create the player as well. Okay, so let's go ahead and create the player. Right, so, but yeah, it's more like me ID. Okay, okay, so this is reasonable. This is reasonable. Seems to be working. Seems to be working. So that's pretty cool. Seems to be working. Seems to be working. All right. Okay, so we can't have two players. We have two players. Received bogus Amogus message from the same expected binary data. That's very interesting. So what kind of messages are we receiving? So let's actually log everything, and I think we'll log in everything, right? So I kind of intentionally disabled all that stuff. Let me see. Okay, so what do we have in here? We received the message, which is blob. This is the first thing we received. Then we received player joined and like a couple of players, like who joined and stuff like that. And then we received... Okay, so this is the error message, by the way. I think I need to, for the bogus Amogus things, I have to indicate that they are errors. Otherwise, it's like not clear what I'm reading right now. Right, so... bogus Amogus. Yeah, there we go. So now I can see what's error, what's not. So first we receive the blob, which sets the player and stuff like that, which sets the player. So that means for the second message, it will go to the else branch of this entire thing, right? So me equal to undefined indicates that we have not received greeting yet. If it's not equal undefined, that means we can receive the rest of the stuff. So after we receive the blob, we should have actually set the player, and we should have not failed at that. So that means at this particular point, expected binary data. Wait a fucking second. Is that because... Oh, it's fucking await. Okay, so essentially it goes into await, and then, like, you know, continues handling the rest of the messages, and we receive the JSON. We receive the JSON before we finish. Oh, this is so fucking dumb. Holy shit. Holy fucking shit. So can I control like what kind of things I can send in here? So can I do something like WebSocket binary message blob to array buffer? Because this is so fucking dumb. This is so fucking dumb. I swear to God, it must be a solved problem, because like I'm definitely not the first person who actually encountered that. Binary type property. Wait. Sounds interesting. Are you fucking serious? Well, I mean, I didn't really have that high of an opinion about web dev, but I just lost all of the respect for web development. This is not a real profession. It's a fake profession. It's a fake job. It's just like it's literally a fake job. Like, I have zero respect to this job. Like, seriously, zero. This is so dumb. This is fucking dumb. Anyways, so let me actually take a look at this thing. So, okay, here's the binary type, and returns a string that indicates how binary data form is supposed. It can be set to change how binary return. Default is so. Wait a second. Array buffer. So binary type. What kind of binary? Okay, so it's a, and it's literally only two of them. Okay. So what I want to do, I want to actually try to just print. Yeah, so we'll already print event. I just want to see what's happening in here. So when I'm doing this kind of stuff. Received message. Okay, so it's data is literally array buffer, so you don't even have to wait or anything like that. This is actually perfect. So, and can I just do data type off, and if you take a look, so we received message object. So it is object. So what you have to do instead, you have to use the instance of array buffer. So yeah, it's true. Okay, so that's cool. So it means here we can do instance of array buffer. Right, so let's actually do you don't have to do that anymore. Okay, so that's pretty cool. You don't have to do await, so that solves all of the problems automatically. And that's about it, because that's about it. So if I refresh the whole shit, I can move around. I probably don't want to log all of the messages. Messages. Right, so and if I go to here, look at that, chat, look at that. Okay, let's make a small break. I need to, yeah, so I need to take a break from this bullshit. So yeah. So, let's define more structures, right? So we migrated a bunch of messages, like one single message to binary, and it works great. And we actually did that in a way that we can continue doing that incrementally. So let's actually move player joined message to binary as well, right? It's gonna be interesting. So we basically have like a combined system where we use both JSON and binary. Okay, so looks reasonable. So let's take a look at how we can do that. So the next message is going to be player joined, right? So this is going to be player joined. And let me find a potential definition for this entire thing. So here are the sizes, and I think I'm going to be putting them in here. And so we have that. Maybe I'm gonna actually, so since hello is hello structure is defined near hello interface, what I can potentially do is, you know, define player joint nearby here as well. You know what will be interesting? Try to remove hello. Let's remove hello and see if it doesn't break anything. Okay, so something breaks in some places. Bots. We haven't migrated bots to the new kind of style yet. All right, that's very interesting. So, and the server also complains a little bit because it was importing hello, but now it doesn't need hello, so that's totally fine. So now only bots. Bots. So let's go ahead and do this thing. So next, next error. Okay, so in bots, we're actually using Node.js implementation of WebSockets. The question is, do I have to do the same bullshit with... I feel like I have to do the same bullshit, right? So when I connect the socket, I probably have to do binary type. So node buffer. So in a node implementation, the situation is even worse. So it's not even blobs, it's fragments. Node. Oh, this is use. What's up? What's up? What's up? Array buffer and buffer are different. So what the fuck is buffer? It extends you int 8. So... And it's a... It looks like a... Holy shit, don't fucking tell me that it's a pure node thing. Right. So... Oh my god. Oh my god. Okay. Oh my god, I'm sorry. Okay. So let's actually migrate this client scheisse in here. So bot.me equals that. So now what we have to do, we have to grip it, grip the expressions. Right, so like so. Let's put it in here. So what we do in here is very interesting. So yeah, we do in the turn. So it means we turn in the bot. We identify in the direction where the bot has to move, and we're also starting the tick timer. So that is fine. That is fine. So we can move this kind of stuff to here as well. And I think generally. Oh yeah, so the interesting thing about the bots is that each bot doesn't really care about the rest of the bots, so we never kind of keep track of that at all. So that's totally fine. That's totally fine. Okay, so let's remove this code, and I'm gonna go to the compilation errors, and we're gonna just fix them. Okay, so this is me, this is a bot me. All right, so WS, so this is a bot. And here WS, this is a bot. I think we don't need question marks in here because WS is not, yeah, it's cannot be undefinable. All right, so I suppose we migrated this entire thing. Now let me just do watch, and I'm gonna go in here. Can I? Yeah, let's go. So let me join this entire stuff. Okay, so we can move around. So we're using the binary protocol for this entire thing. And now I'm gonna do run bots. Bots. All right, so that seems to be working. That seems to be working. Look at that. It is working. It is in fact working. And now they're all gone. Cool. So I think it makes sense to maybe commit whatever I have already. So yeah. Migrate hello message to binary. So I'm gonna have a commit message per we're gonna have commit per message. That's what we're gonna have. I'm gonna push that in here. All right, cool. So now, common thing that we share between all these things, player joined. So that's very interesting. Expert const player joined struct. So the difference between player joined and hello is that hello is addressed to you. What it says is that hello new player, you are this person, right? So you have this ID, X, Y, and Hue. When player joined, it's just a notification somebody with these parameters have joined. So hello is about you, player joined is about somebody else, right? So that's basically what it is. But apart from that, they basically the same structures, honestly. Like I can even copy paste them like so. Look at that. Right, and I can probably do something like equals in here. It's pretty cool. It's pretty cool. It's pretty cool. And I wonder, I think I can just try to remove player joined, so to prompt compilation errors in all of these places, right? Yeah, so now everything is broken. And I can just go to the compilation errors and fix all of them. Okay, so next error. So we don't have player joined, which is fine. Next error. Okay, so reconstructing the state of the other players. Oh, this one is interesting. This one is really interesting. So when you joined, we sent hello to you, and then we reconstructing the state of the game, meaning that for every player that exists, we send in player joined event for you, so you can then register all of these players on your side. So this is basically what we're doing. Right, so, and we're not sending joined to yourself because you already know about yourself through the hello message. All right, so and in here, we're also like sending player moving messages, right? So because maybe somebody is currently moving, we also want to notify you about that, which is rather interesting. Okay. So this is where we can optimize some stuff a little bit. This is where we can optimize some stuff a little bit. Moving, if you take a look at the player, where is the player? Moving. It's a type, it's actually 4 booleans. It's actually 4 booleans. We can take, we can allocate a single byte within player joined event and just encode all of these 4 booleans in there. So then we don't have to send additional player moving, right? So you joined, you received hello message, which identified you. It gave you ID, it gave you X and Y and Hue, and then you receive sequences of player joined. But then you receive a sequences of player moving because some of them can be currently moving. So we can remove player moving completely and just actually include the moving mask, those greatly reducing the amount of messages we have to send to new players. So yeah, so we're gonna have bit fields and stuff like that. So that's actually kind of cool, I think. So that will require, I feel like, extending the definition of the structure. So let's actually do player joined. Where's the structure? So this is a hue, and this is going to be moving. All right, so I'm going to allocate uint uint8 field. So this is another allocator in here. Right, so that's actually super cool, I think. Look at that. Look at that. Look at that. Look at that. Cheers. So hue and moving, and so on and so forth. Okay. So in the server, so this is what we're sending in here. So okay, so I'm gonna do array buffer, and I'm gonna just do common player joint. Is it size? Do I even have size? It's a struct. Yeah. So player joint struct, and then we wrap it into the data view. So then we just have it like that. Okay, so now we need to do these things. Common, it's a new, Azozin, a new player joint struct. Right, kind right. So right accepts the view, then the offset, which is 0, and then we have to do message kind player joined. Come on, yeah, there we go. So it's, I think it's part of the common, like so. All right, so the next one is going to be ID. An ID comes from other player ID. Then we have X, and this is X of the other player, Y of the other player, hue of the other player. So in the hue we have to divide it by 360 and multiply by 256. So maybe I just have to store the hue in 250. Well, I mean, it's not gonna. Yeah, we'll see. It's kind of dumb, but it is what it is. So it can be fixed later. So this entire idea was actually developed before we were serializing binary stuff, so it's fine. And on top of that, I want to have the moving, and I need a special function that takes the moving type and converts it into a mask. Right, so I can have moving, which is this thing, which is just that. Right. So I think we can introduce something like moving mask, and it's suppose it's going to be part of the common. So it's going to simply take this type and convert it into a mask, so you can then write it somewhere. So let's go in here and let's also export this entire thing. So function moving mask is going to accept moving and returns a number, just like that. So how are we going to be approaching all that? This is rather interesting. So we can do something like object keys of the moving, right? And those things, I wonder if they are in the correct order. That's the problem in here. That's kind of the problem. So the order is not defined at all. This is really annoying. One of the things I can do probably is something like that. I can do keys, and I'm gonna just say that this is a direction, right? And the keys are here, but then I'll have to add a to-do to kind of fix that later. All right. So I want to preserve this specific order, directions for direction in directions. Actually, yeah, so let's first of all do a to-do. It's really easy to forget to update this array if the definition of type direction changes. Right, so I need to do something about that, but I don't know how exactly do that yet. So I'll do that later, and it's not really that important. So direction vector, it doesn't preserve the order. So the order here is very important. So I'm going to do the following thing. So we're going to do it like that. Directions length. And it doesn't matter. Again, it doesn't matter. It can be fixed later. Right? It's just to do. Don't get wound up about it. So this is the mask. And yeah, essentially if moving directions I, we increment this mask. So we just do something like this. So I and just mask. There we go. So and then we just return this mask. That is rather interesting thing. Is it going to work? I think it's going to work. So let me go to the node. So if I have x1 and then I do 1, okay, and then I do x, it has to be or, yeah, it has to be actually or, not and. Okay, that makes sense. Cool. So yeah, that's literally it. If I go to the server, now it is updated, everything seems to be fine. And now we should be able to send this entire thing. So where do we send? So this is a joint player, player ws send view. Right, so we send a view. So in terms of bytes, how many bytes we send in here? So this is bytes send counter plus view bytes byte length. So we don't need that. and this is the message count. So here order doesn't matter, so we can do it like that. The only reason, again, I introduced this array is because the order matters, right? So, and I'm not sure if object keys preserves the order. Like, I need to research that. I'm not a JavaScript developer, right? I don't know this kind of shit. And again, it doesn't really matter that much. Okay, so this is what we got. Everything seems to be Gucci, and maybe even potentially Tamaguchi. Look at that. So this is that. So maybe I have to go to the next errors. Okay, so notifying who joined. So this is basically for the rest of this stuff. Joined player. This one is interesting actually, because we can construct this thing once, right, and just send it over and over again, because we iterate in others, but the joined player kind of stays the same in here. Okay, that's kind of cool. Player joined. Let's go up and let's steal some of that stuff. Right, so now we'll go next error, and I think I'm gonna be doing it in here. So this is the joined player sent. We are constructing the joined player in here, right? So that's the joined player. And then we're just sending all of that stuff in here. So we're sending the other player. Yeah, so we're sending the joined one. And we can just keep it like that. So we just rendered this entire thing once, right? We just rendered it once, and that's about it. Oh, okay, so it might be actually missing. So that means we have to put it behind the condition. All right, so this is behind the condition. So we serialized it like that, and then we just do it like that. Yeah, that's fine. That's fine. Okay, seems to be compiling. So what is the next error now? A player moving event. I don't really understand what you're talking about, bro. Implicitly has any, because cannot be used to index expression. A player moving. I don't get it. So because event queue. Damn, this is very interesting. Okay. So apparently we do need player, like this kind of events, because we have two parts. Right, we have two parts. We have two parts. We have the tick, and we have the thing that accumulates the events and stuff like that. So yeah, so we'll have to do that. So we have to preserve player joined. So I rushed to delete it too soon, I think. I rushed to delete it too soon. So let's bring it back then. So might as well actually just like, yeah, so we're gonna keep them both. Player joined. Where's the common MTS? Player joined. So this is gonna be somewhere here. All right, so so that seems to be fine. So we keep both of them. Okay, and it compiles. All right, but that's annoying because I was using errors as the way to know where I have to fix things. So I have to put underscore in here. Okay. So let's put it like this. So this is that now. So where is the rest of the errors? So this is the next. Event queue. So in here, I just have to update that. All right, so that updates everything automatically. So, and there's no errors anymore. Okay, so everything compiles. That is perfect. Okay. Let's go. So let's open this thing, and we can move around, right? So, but we don't receive any player joined yet. So let me open the dev tools. So let me open the DevTools and let me just do that. So it should now fail. It didn't even fail. So can I just move around? You're supposed to break, bruh. I think I just have to restart the server. Okay, so I just forgot to restart the server. Everything, we are in a watch mode, so everything gets, okay, so it's kind of funny that it automatically recompiled. Okay, so this is fine, we can move around. And now if I refresh this thing, yes, that's what I expected. Thank you. Okay, so it just couldn't parse the array buffer because it received a binary thing. Cool. So let's go into the client, and in here, so essentially we just parse the message as it is. What we have to do instead, I think, is we have to check whether the event data is instance, maybe even something like the instance of array buffer, right? So if it is instance of array buffer, we do one thing, otherwise we do the other thing. So, and this is where we have to do the player joined stuff. Right, so this is that, received bogus message. All right, so how we are even approaching all of that? Shut back up. Okay, so this is gonna be this. So we got the view. Delete trailing white spaces. Okay, I got the view. If so we're specifically expecting the byte length to be equal to common player joint struct size, right? So it's equal to that, and I suppose the first byte, so common player joint struct kind read view at the offset 0, and it has to be equal to the message kind player joint. There we go. So if it's something else, we're gonna say bogus amogus. So this is a bogus amogus. So message kind. So do we have to put common in here? I think I have to. Yeah. So there we go. So it's a little bit big, but I mean it can be refactored later. It doesn't really matter. Doesn't matter, bruv. Doesn't matter. Message bogus amogus incorrect. Player joint message. There we go. So we get that. So and in here we just have to do this kind of thing. So we have ID. So let's read ID. Common player joint. So it's more like a player joint struct ID read from view 0. So we read the ID. So then now we can do players set message. It's actually just ID and X. We're reading X separately. So this is X, this is Y. Moving is going to be really interesting. So we need a way to convert moving back. Moving. So we can say something like moving from mask. So we can do something like that. So we're reading that, and this is going to be moving, and hue is going to be just hue. So we divide by 256 and multiply by 360. So yeah, that's about it. Let's actually construct moving from mask. Moving mask. So let's export function moving from mask. So here we accept the mask that we're going to be converting back. And we're going to be returning the moving. So, okay, we kind of need this thing in both cases. So I'm going to just move it like this. And what I'm going to be doing, I suppose. So moving is going to be, I'm going to explicitly say that it's that left false. This is not what I want. Emacs, you're getting crazy. Emacs, shut the fuck up. Jesus Christ. Okay. So up, down. Alright, so in here, if mask I this not equal to 0. See mantra, thank you so much for tier 1. Thank you, thank you, thank you. So what you don't like, bro? Okay, so that's what it didn't like. We just say true. Yeah. So something like this, and just to return the movement. So we're constructing this and that thing back. So we'll probably also have to have a moving set moving mask in the future. I have a feeling that we'll need this function, set moving mask, where you accept the moving and you also accept the mask. And what it will do, it will just set things correspondingly. Which probably, and like moving from mask could be implemented in terms of this thing, I feel like. So essentially here, what we can do, we don't even have to return anything. So we just iterate in the directions if this is true. Well, I mean, I can even factor this entire thing out like so. So direction I equal to this, boom. We don't have to return anything. And essentially now I can just set moving mask like so. And on top of that, this also creates a new thing. So this one sets the existing thing, this one creates a new thing. Yeah, that makes sense. Sure. Okay, so that's actually kind of good. I like where it's all going. So moving from mask, so let's put it in here, in here, in here. I mean, yeah, so this one has to be like this. Okay. So everything compiles, everything seems to be compiled. So now we can get notified about joint players and stuff like that. And we can get rid of this thing completely. So we're slowly moving the JSON messages into the binary messages. And at some point we're gonna only have binary messages and something else and nothing else. And we will be able to get rid of these checks, which is perfect. Right, I really like that. Okay, that's pretty cool. Our number essentially is passed by reference value by value. So that's the most annoying part of JavaScript, is that they're passed by value. If you want to pass them by reference, you have to pass an object. So I'm gonna show you. It's kind of dumb, but it is what it is. So essentially, just mod. If you want to pass something by reference, like for example, you want to return a pair of values without creating an array or anything like that, right? So something like return pair. So you have to, you know, accept pair as an object, right? And then you just set things like that for 20. So and essentially, to get a pair out of the function, right? To get a pair out of the function, you have to first create such pair, right? Const. Like just initialize these kind of things, and then return pair. Right. So I mean, you don't have to do that. You can just return an object or return an array or something like that. So, but sometimes you want to make a function that returns a pair of numbers but doesn't create a new object. Well, that just means you have to create the object outside of the function and pass the object. And this is how you pass by reference, because objects are passed by reference. Any primitive types are passed by values. So that's how it works. It's extremely annoying. Anyways. So yeah, well, let's actually test if it works or not. Let's actually do the testing. So let me restart the server. Super quick. And I'm gonna just refresh myself. Okay, so here's me. And I'm gonna join. And that seems to be poggers, actually. The colors are fucked up, by the way. It's super funny. The colors are fucked up. The hues, you can see that. You can see the hues are fucked up. So hue. Okay, so let me see what we do with the hue. So maybe hue has to be a value from 0 to 1. Maybe it has to be a value from 0 to 1, but I don't know. I don't know, man. So do I want to spend some time refactoring all that shit or not? I'm not sure, actually. Hue, right. So we take the hue and we just multiply by that. Okay, so that makes sense. So that is correct. Hue, right. And another one, another. Okay, so that makes sense. So divide by 360, multiply by 256. So on the server side, it is correct. Hue read. When I'm reading, yeah, this is really interesting. So where is the other hue? I see. So this has to be hue. I'm still making mistakes in here. That's what's funny. Even though I created this like very convenient framework for things, I still make mistakes. Yeah, okay, so that's fine. Everything seems to be fine. All right, that's cool. We migrated yet another thing in here. Player joint. Migrate player joint to binary. There we go. I'm gonna push that right into the repo. And by the way, so we don't have to send the movings anymore, right? So reconstructing, yeah, there we go. Since we have this moving mask, we don't have to send the rest of the moving messages in here. We don't have to send it. So there is a very interesting thing. So I kind of need to roll back to what we had. So I'm gonna roll back to the state before the stream, right? So whatever we had before the stream. All right, so I'm gonna restart this thing. It's a watching mode. It's taking some time. Like what the fuck? All right. So let's do the surf. Let's do the surf. And one of the things I want to do, actually, I want to run the bots. So to create a bunch of bots. And I'm going to refresh. And as you can see, we just joined and they're moving around. And they're moving around more or less correctly. They're moving around more or less correctly. So now, if I remove that particular part, if I remove this particular part in here that restores the messages, reconstruct, yeah, so there we go. So we send the joined and then we send the player moving. It's going to be completely broken. Yeah, so because I think what's going to happen is that when I join, they at first going to be all standing until they make a turn and only then they're going to be moving. Right, so that's basically what is going to happen. So I updated, I need to restart the server. All right, so I'm starting the bots. Bots are connecting and I'm gonna first connect. So at the first, some of them are gonna be standing, which is not correct. Yeah, have you noticed that? I can even refresh that. So at first they're standing, and then as they make a turn, as the state synchronizes, only then they're like teleporting and stuff like that. So this is literally why, along with player joined, we also send where they're moving. But since we migrated to binary protocol and we send the moving mask along with the player joined, we don't even have to send these extra messages anymore, actually. We don't have to do that anymore, like at all. So let's actually go back to you know, binary protocol that we just implemented. So we already have advantages in here, so that's cool. So where's the main? Yeah, there we go. Okay, so we're already optimizing things. We're already optimizing. Okay, so here's the binary thing, and if I do the server and I need to reconnect the bots, the bots. the bots. The bots. Oh, it didn't work properly, unfortunately. So that's bizarre. Oh, okay, so yeah, I see what's going on. So the bots also need to be migrated to the new kind of style. So this is bots, and when we receive array buffer, we do that. Otherwise, is player moving? Oh, okay, I see. So I suppose here what we have to check is event data. I can even do something like type of string. So that's what we want. Okay, seems to be compiled. And yeah, so that's a lot of bots. Like, what? I don't need so many of them. Come on, bro. Oh, it's ID. It's not the amount of bots I'm gonna do. All right, so I just join, and they're moving right away. So they're not stuck at first. They're just moving right away. All right, that is cool. That is cool. So now I can remove from the server this specific chunk. I'm removing this specific chunk, and it's not going to break anything because this information is conveyed literally by this, right? By just sending the moving mask. So that's pretty cool. I really like that. Okay, so everything seems to be recompiled, and let's serve the server. Let's restart the whole thing. Okay, so how many bytes we send per tick? We still send a decent amount of bytes because it's like moving updates and stuff, right? So that's totally fine. So I'm gonna go here, and yeah, so it's instantly moving, so everything is correct. All right, I really like that. That's perfect. So we can literally remove this chunk of code that was sending a lot of data. Well, probably wasn't sending that much data, but I mean, was responsible for pretty good chunk of data that we were sending. So yeah, all that is binary stuff. So let's do bots. Ignore irrelevant binary messages. And in here, it's gonna be server ignore. Don't send redundant player moving messages, and I'm gonna push that right into the repo. Actually, I need to push that to the main rather than your mom. For some reason, your mom is my default remote, so every time I push, by default, it's pushed into your mom. Your mom is the name of the server. Okay, so what's next? We need to start working on the next of the messages, right? So player joined, right? So here's the player joined, and the next one is player left, right? So, and this one is actually super easy because it has only two fields. So it's literally the kind and the ID who left. So super easy, should be. So join struct player left. Let's put it in here. So this is joined, and this is gonna be left. So thank you for the raid, infinite code 01. Hello Rages, how are you guys doing? So let's put it like this. So this is gonna be kind and ID. So we broke up a couple of things, and excuse me. So next fly check next error. So I probably have to do something like this. Doesn't fail, unfortunately. So something is broken with my fly check, I think. Yeah. So we don't need that. Well, I mean, it's just this. The fan. I'm not entirely sure how exactly it's gonna go, but whatever. Next error. All right. So notify who left. Notify who left. So that should be very easy. if you ask me. So here's the view, player left struct. So the kind is player left. Okay, so we'll have to introduce this kind of thing. So player left, and here we have kind is already set. And this is the player ID, and that's about it. Yeah, that's about it. So we're then take player WS. No, it's a left ID actually. Left ID. And we'll probably want to serialize it here, right? So we're iterating all of the left IDs. We're serializing this message once, and then we're iterating through all of the players, and we're just sending them the view. Right, and the byte counter is just the view byte length, like this. Yeah, there we go. So now we're notifying about the left players. Okay. So next error. What is the next error? So player moving. This one is interesting because we're iterating the event queue. When I push into the event queue, what I push? Player left. Yeah, I see. Event. Yeah. Are you okay now? Oh, right. So next error, it still complains about this shit. So type any. So event player, there's a bunch of events. It's a player left. Did I actually put? I put underscore in the different. I'm not consistent with how I just do this kind of. Okay. All right. So whatever. It's too late to fix anything. Yeah, are you okay? Okay, seems to be okay. So, yeah, in a common, I'm gonna remove all of these types anyway, so it's fine. It's fine. But chat, don't worry. Don't worry, chat. Don't fucking worry. Don't even. What? Oh, it's not even consistent. So for the left, it's on the right, and for the right, it's on the left. I'm sorry. So let's go to the client. Motherfucking client, bruv. Motherfucking client, bruv. So, yes. So this is the player left. What we have to do now is we have to take this thing and check. So this is the player joint. I can actually select something like this. So player left. When the player is left, what we want to do, we want to simply remove the ID from that thing. So it's going to be common player left struct, and we take ID and we read that ID from the view, and that's it. So yeah, it's just that. Pretty easy, pretty straightforward. So the only thing that we'll now have to migrate is player moving. So yeah. So everything seems to be compiling. Let me restart the server. Right, and I'm going to just run the bots. The bots are running, right? So let's join. Everything is Gucci. Everything is Tamaguchi. So now let's check how it reacts to player left. Does it remove all of them? It does. Okay, so player left are actually working correctly. Right. So what does protobuf actually solve? Probably some sort of organizational problem of Google. Just like any frameworks from Facebook, Google, like some Twitter or whatever the fuck. So none of them solve any of your problems. They usually solve their internal organizational problems. So all right, so let me see. That's actually, I know, right? So because I worked in big corporations, I know how it goes. All of that is just solve their internal stuff. And so releasing all of that publicly also kind of makes sense, because they project their internal structure to the outside world, right? So that's what they do. They project their internal structure to the outside world. And why is it beneficial for them? Why is that beneficial for them? So the potential new employees, right? So will get used to that structure. So it's easier for them to integrate people into that structure, right? So they sort of inoculate the environment. I don't know, okay, but I feel like the word, that specific word here fits perfectly. It's just they inoculate the environment, so then they can grab all of the people and just, you know, integrate them into their structure. This is how we ended up with Kubernetes. Exactly. That's what I'm talking about, bro. Exactly. All right. Okay. So migrate player left message to binary. I'm going to push that into main. Google 8 Olorama programmers. Yeah. So is it pushing? Is it? It's not pushed into your mom, so that's fine. All right, so what's the next message? So the last message that we have, well, I mean, there's quite a few messages that are sent from the client to server, like I'm moving. And this one is rather interesting because I'm moving could be literally a structure with the moving mask. Right, so here we have start moving, stop moving, that doesn't fucking matter. Just like send an entire mask. Yeah, I think that's gonna be great. Swolver, thank you so much for 86 raiders. I was about to make a break because I need to take a piss. Hello everyone, so let's make a break. Okay, so let's migrate the rest of the things, right? So the next one is gonna be player moving. Right. And essentially, instead of like having start and direction and everything, let's just send the moving mask, right? The entirety of the moving mask, and it kind of solves the entirety of the problem. So I think it's a good idea. Right. So let's go ahead and just do that. So player moving. Also kind of similar to ammo moving. So the difference between ammo moving and player moving is sent from the client to the server, and player moving is sent backwards from the server to the client. So that's the difference between them. Right, so player left, so player moving, and in here we're gonna have a kind, then ID, then we're going to have x and y are going to be floats, obviously, right? So they are floats. So this is y, and we're just going to have moving. So, and moving is a mask that replaces both start and direction. All right, that's cool. So, but this thing is going to be just simply uint8. Right, and everything seems to be all right. So let's go to the compilation errors super quick. So this is that. Next one, this is that. And what's the next error? All right, so I think that's it. Right, so I don't see any more errors in here, so no more errors. Let's go into the server and let's fix everything. Yeah, okay. Next one, next error. No errors, really? What the fuck are you saying, bro? Player moving. Okay. So when we're sending... Okay, so when we're handling the player moving situation, notify about movements. This one is interesting, actually. This one is actually very interesting. we probably want to we constantly receive moving and we sort of accumulate them, right? So we sort of keep accumulating them. What if we also just simply mark the players that have moved and we generate the movements for them automatically? So there is this interesting paradigm. Where I first collapse such events as player joined, player left, and so on and so forth. This is a very interesting paradigm. So essentially, the server receives messages. Player joined with some sort of ID. Player joined 2, player joined 3, and then maybe player left 1. Right, and let's assume that within a single tick, this is the messages it received. So as you can see, within a single tick, a player joined and then left. So we kind of don't want to notify the players that within this single tick somebody joined and left. So they left no impact on the server. What's the point of even notifying anybody about this kind of situation? So one of the things we do on the tick, we iterate through all of the joined and left events and we kind of collapse them. If there is a corresponding left for the joined, we kind of like just remove them. We just remove them. So that's basically what we do. Right, and we have these two sets, joined IDs and left IDs. We iterate through the events. If the player joined, we add them to the joined IDs. If the player left and it exists within the joined IDs, we remove that. But if it doesn't, we add it to the left IDs. And so this is like basically grouping and collapsing of these events within a single tick. And then after we've done that, we separately iterate joined IDs, doing notification for the people who joined within a single tick, then separately iterating left IDs and doing all of that stuff. And only then iterating player moving. So for the player moving, I feel like we want to do kind of a similar thing. So essentially, if somebody moved, we're gonna add them to the moved IDs. So that sounds interesting, actually. Somebody moved. Or, so we have player with socket. So this is not really player with socket. It's more like a player on server, right? So player on server. It's basically the player, right? ID, X, Y, moving mask, hue, and stuff like that, but with additional information, which is socket right now. So one of the things we can add in here, we can say moved. And essentially, as we collect all of the events, if we receive I'm a moving event, we're gonna just mark the player, as moved. So on the tick, it is going to notify, the rest of the people, right? So we don't even have to do that. So yeah, so we have joint IDs, left IDs, and so on and so forth. So Phantasma55, thank you so much for tier 1 with the message. Idea for the normies RTS game. Does anybody even still play RTS games? I thought this genre actually died a long time ago. It kind of killed itself at some point. So player left is the same as player exit. Yeah, exactly. It's the same. All right. So interestingly, I feel like we could perform this collapsing at the point of collecting the events. I think that's what we can do. So how many changes have I made in here? How many changes? I kind of want to, yeah, so what I want to do is literally get rid of the player joined and player moved structures, like literally get rid of these things. And I think I know how to do that. I hope I'm not gonna get stuck. I may actually, but it's besides the point. So now event is going to be only player moving. All right, so do we have any errors anymore? Okay, no errors. In the server, let's take a look at this stuff. Right, so we don't have this thing. All right, so let's take a look at the errors. Next error, fly. Okay, next error, come on. Okay, so player set, so players and players set. Why can't I set this player in here? Is that because moved? Ah, I see. So because I have to do moved false. Sure. Next error. What's the next error? This is what I'm talking about. So we adding player joined. But what I think we should be doing, we should be doing that thing, that collapsing thing that we do in a tick. Right. So we just do this. So joint ID. Right. So that's what we're going to be doing. And that actually means that we don't really have to... Oh, okay. So the player joined counter, player currently counter. Okay, so that's fine. That's fine. All right, so the next one, fly check, next error, and this is kind of the same thing, right? Instead of doing player left, IDs, we just do that. So we just do that, and I can remove it from here. So this is, what was the, it was just the ID. And all of that happens within a single, so the frame. So now we can get rid of that. And now we can put that at the end where we clean the event queue. All right, so where we clean the event queue. And what's funny is that at some point we can even get rid of the event queue. That's the thing. We don't need it anymore. Because now when I receive I'm a moving, so what I'm doing in here, I'm pushing I'm a moving into the event queue. Instead of doing that, let's for the player, right, so who's the player, or like for the ID, right, so let's do it. Players, Kevaron28, thank you so much for tier 1, thank you. So we're gonna get the message ID, so, and that gives us the player, so we get some sort of a player. So if player is, so message, oh yeah, we already know ID, right? So we already even know the player. So we can just say player moved and true, and that's it. And we can now get rid of the event queue. So instead of event queue and accumulating the events for the tick, we accumulate the difference within a single tick, and then at the end of the tick we're notifying everyone about that difference. That is insane. That is so fucking cool, actually. So yeah, so we were accumulating the events then to handle the tick. We don't accumulate that, we accumulate the diffs, because things like joined IDs, left IDs, and players that moved, maybe we should do something like moved IDs, I don't fucking know, right, so moved IDs. All of that is just a diff between the ticks. It's the diff between the ticks. This is a very interesting way of thinking about it. I really like that. I really fucking like that, mate. Really fucking like that. But of course, everything is broken, so let's actually go to the compilation errors. Next error, so whatever. So event queue. So here we're doing notification for this stuff. We don't have to do that anymore. We really don't have to do that. And what we have to do is to iterate through all of the players, and if the player is like moved, we are sending information about that. So let me do players for each. So this is the player. So this is the player. This is the player. And if player moved, so we're gonna be sending notification about that. First of all, we have to like clean it up after we've done that, and then we do sort of like an internal thing where we iterate through all of them. So this one is kind of annoying in the sense that this is like a quadratic square, right? Square algorithm, but maybe that's fine for now, right? So let's say other player. So we can optimize it and collapse it a little bit later, so it doesn't really matter that much. So, and this is where we're gonna be sending the player moving, right? So somebody moved, so we notify everyone, like everyone to everyone who moved. If we implement batching of the messages, we'll be able to just like iterate all of these things, batch them up into a single message and send it as a single message, right? So this is what we can do. I really like that. I really fucking like that. Okay, go. So let's go ahead and do that. So the other players, so I suppose for this one we have to just create the thing. Concatenating messages in 2024. Yeah, that's what we're gonna be doing. So player moving struct. It's more like a player sync, right? So kind of syncing the player rather, in terms of like syncing, not syncing, but syncing. You know what I mean? So this is the size. Then we allocate array buffer like this, and then we have a new data view like this, and this is the view like this. What are you syncing about? The classic German ad. Love it. Okay. So now what we have to do, view kind, not really kind, but common player moving struct, kind, right, view offset is 0, offset is 0, and value is message kind player moving. Do we have such thing? I think we do. Nah, we don't. Player moving. So that is fine. So now the rest of the thing, player left, not player left, but player moved, player moving. Right, okay, ID X. So now this is ID, which is the player ID. Alright, so this is X, X, Y, Y, X, X, Y, Y, and moving. So this is the moving, common player, moving mask, Okay, we serialize this shit. Now, what we're going to be doing is we're going to be sending all that. Cool. So let's do other player ws send view like this. But then we have to do bytes send counter, right? So we have to increment view byte length and also message sent counter plus. It's not really message sent, it's more like a packet sent, right? So I think we should think about them as packets. So yeah, this is how I want to go about that. So, and we don't need this thing at all, right? Notifying, yeah, none of that is needed. I really like this idea of just accumulating the diff right? So accumulating the div and then notifying about the div. So tick message received. This is how messages you received. So this is not exactly how we want to go about it. Tick message received. So we have to count now count them somehow differently. Since we got rid of the event queue, it is not particularly possible to, to use it like that. Right. So player moving. Yeah, it's not used, I suppose. None of that used anymore. All that is redundant. So let's go to the next errors. So it means now within the message, right? So within the message, where is the message? I don't see it. Maybe it's something like message connection. I don't see it. Where is the problem? Okay. Oh yeah, here it is. Messages received. So this is the total messages received per tick. So this is bytes received within tick. Why can't we have messages received within tick? And this is just +1, and we can see. So let's bytes received within tick. So we increment that, and then we set it to 0. And this is messages received within tick, and this is messages received within tick. So why don't you like so I probably misspelled it somehow. I don't really know where exactly it's. Oh yeah, I see. Okay, so there's no errors. I guess I refactored everything. I guess everything is refactored. So I managed to get rid of the event queue, which is something I didn't expect to do today, honestly. I had like a rough plan of how the thing is going to look like at the end of the stream. And this is the last thing I expected, to get rid of the event queue, honestly. It's kind of bizarre, but maybe it's completely broken. Maybe it's not going to work, but yeah, it's kind of cool. So we get rid of that. So now we need to test if it still works. The fact that you don't need event queue is so cool. Okay, that expands my understanding of how you make this kind of games. I really like that. I really like that. Testing time, yeah. So we need to test, like, we're not going to do performance testing or anything. We just need to do the smoke test, right? So maybe it's completely broken, I don't know. All right, so are you working? Are you working? All right, let's connect. Okay, so disconnected, and I wonder why. So let me see. I don't see any errors though. Okay, so maybe it's something on this side. I think I know what exactly is going on here. Yeah, it's the client side. We haven't migrated to player bogus amogus player joined. Incorrect player joined. Oh yeah, I see. So that's fine. Incorrect. Yeah, so I wouldn't. Yeah, this is not how we want to go about that. So player moving, right? So this is going to be player moving struct, and now what we're going to be doing is very simple. We need to only sync x, y, and moving. So we can get common player moving struct read has to be x read view 0. So we're just reading that. But we also need to actually read ID first. So let's actually read ID. We don't, yeah, so this is something that can happen. We can even copy paste some of that stuff. So this is going to be the ID. So this is the ID. All right. Bogus, we don't know anything about player with ID. Let's get rid of that. I'm being really careful. So this is what we want to set in here. Okay. So player moving. So what you don't like in here? Yeah, it's bizarre, but whatever. Player moving. So common set moving mask. Right, so we're setting the moving mask, but the question is, what is the mask? We can just set it like this. So this is going to be that, and this is going to be that. All right. So now let's read X and Y. So we're going to be also setting X and Y in here. Okay. So we might as well actually read all of these things after we identify the player. All right, so all right, that is good. So we don't need that stuff anymore. And we don't have anything anymore, in fact. So we only have this shit. I guess we, in terms of receiving messages, we fully migrated to binary protocol. As you can see, in both of the branches in here, we first check that we are within the binary stuff. That means we don't have to do that anymore. So we can just always assume that it is binary protocol. So we fully migrated to binary protocol in terms of receiving messages, not in terms of sending them yet, but in terms of receiving them, we fully migrated to binary protocol, which is good. Okay. So when we send in things, like we still have ammo moving, but this one is easy, actually. This one is easy. This one we can just send the moving mask. Okay. Let's go. Okay, so let's refresh. Okay. And all right, bogus and bogus messages. That is bizarre because I don't handle moving. Like, I thought I do handle moving. Wait a second. I thought I do handle moving, and here it is. Player undefined. So bogus received bogus and bogus message from the server, and it's really unclear where exactly that happens. So it looks like moving struct is incorrect. That's what it feels like. Maybe I just need to restart everything. Maybe that's what happened. No, it's still when it receives something, but I know that it receives something from here. All right, so that means it couldn't properly do the move instruct. Okay, so server MTS and moved. All right, that. I wonder what exactly happened in here. Right, because we allocate this thing, and you right. So the size. So maybe message kind is wrong. Yeah, so message kind is wrong. Yeah, thank you. I can see that. So it's a little bit long, but I'll factor it out a little bit later. Right, so I'll make it look a little bit nicer. Thank you so much. So yes. Okay. Fucking doesn't work. All right. Set moving mask. Okay, so let's try to maybe log the messages just to see. So now at least it parses them, right? So that's good. Received message. Okay. That's very, very good. It doesn't update them. This motherfucker doesn't update them at all. Set moving mask. So did I do that correctly? So first I'm just moving it to the right, taking one out of that, and yeah, so that seems to be correct. So setting mask maybe on a server, we get to moving mask. Maybe moving mask is not correct. I don't know. So let's try to now in here take a look at the moving mask. So it also resets all the, yeah, so if it's false, it's going to be correct as well. So let's do console log player, just player. Let's take a look at the entirety of the player. So, okay. So it doesn't show moving, I have to expand it. Yeah, it doesn't set anything, unfortunately. So I'm holding and bruh. It is, all of them is false. That is unacceptable, honestly. So did I forget to, okay. So it's 0. It literally sent 0. Oof. Oof, oof, oof. Why did it send 0? Moved. So player moving. So when I received ammo moving, because I never actually sent, okay, so that explains it. So what I have to do is in here is just moving, and then I take the direction, right? So I take the direction and message started. Yeah, start. I forgot to do this thing. Luckily I actually found it, right? So luckily I found this problem. Okay, so that's cool. Okay, it's moving, finally. Finally it's moving. So I was complaining about something. Okay, so that's fine. Right, so now let's take a look at the client and let's get rid of that. Let's get rid of that and let's also do it like that. All right, so we're moving around. So can I connect the second player now? Can I connect the second player now? Okay, so the second player is connected. And now I'm gonna try to run the bots. So they are moving. So they are moving. So average bytes sent per tick. That is actually cool. Look how many bytes we sent per tick. So that is way less than we had before. It's like a magnitude less. Also, we still use JSON for ammo moving. We need to get rid of the ammo moving. So it should be really easy to introduce that. So it's going to be kind, then ID, and then moving mask. How many we had before? Around like 5 kilobytes or something. You ask in a very inconvenient moment when I was already in the flow. All right, so okay. So just a second. It's magnitudes actually. It's magnitudes. Let me do everything. Let me just check that everything is correct. No, it's fine. It's fine. I'm also interested to see what's the improvement. It could be improved even further. It could be improved even further. All right. So migrate player moving to binary. Right, and let's actually go to before the stream. Right, to before the stream. So let's recompile. Come on, you can do that. All right. So, all right, let's go. 7 kilobytes. 8, like 5, 7, 8 kilobytes. This is how many we have. Like this is how many we were sending to the players just to notify them about the state of the game. And we shrink it down to 500 bytes. by using binary protocol. So that's pretty cool. All right. So we can now go back to here, right? So that we compile, run that. So this is the server. Run it. All right. So this is the average bytes sent per second, like 500. So it's pretty cool. And so yeah. So it's in terms of sending. So I don't think I can like improve that thing that much. But I can definitely improve receiving the amount of bytes, right? So because we're still receiving JSON, I can reduce that as well. So okay. Let's go. So now I'm gonna create a struct for this thing. I'm a moving struct. I'm a fire in Malaysia. Okay, so this is gonna be kind ID and just moving. Yeah. So it's gonna be moving. Emacs. Should have a copy Emacs. So this is gonna be 8. And I think I can right away just like remove this entire thing. We don't need that. So I'm a moving struct. So ID moving, and you just send the current moving state, and that's it. So next error. So there's no errors in here. What about the server? Next error. So I'm a moving. So I'm pretty sure there is I'm a moving. Yeah, but I mean, wasn't it removed? It was removed, so that means there should be an error in here, bro. Yeah, that's what I'm talking about. Show me the error, or maybe, yeah, finally it found the errors. Yeah, this is what I'm talking about. Okay, so on the server we're receiving I'm a moving, and so it means, yeah. So as you can see here, we're receiving JSON only. So that's kind of interesting. Honestly, like the server receives a lot of messages, right? So a lot of messages, and not being forced to parse them as JSON could be beneficial for the performance, actually, if you think about it. All right, so bogus and bogus messages counts. Yeah. Yeah. So let me see. What's the type? If I'm sending, let's actually start with the client. I think with the client is a little bit easy, right? Because then on the server we'll be able to see how, like, what exactly is wrong with the messages. So we don't have a moving. Next error. Okay, cool. So on the server, new array. So I'm allocating a moving struct size. So here the kind is AMA moving. So I think there's no AMA moving there, yeah. AMA moving. Okay. So, and in AMA moving we have ID. This is not that. Moving struct. So we have kind, ID. Do we have X and Y? We don't have X and Y because this is from client to server, and client has no say in where it is located. So that's totally fine. So this is moving, and so this one is the me. Me moving, common moving mask. Yeah. So, and the rest of the stuff is not needed here. Okay, and then we're just sending that stuff. So just send view. Okay. And we can even repeat the whole thing. So what we can do now, we can do moving direction true. And in here, it's literally the same, except this is false. All right, seems to be compiled. So there's no errors. errors. Let's start the server. The server is going to be expecting the JSON, but we're going to be sending we're going to be sending a row. I kind of lost the error. Where is the error? I think it didn't say anything regarding the error. God damn it. So get fucking damn it. I need to find the moment. When I receive this message, and the only thing I want to know is what its type. What it is type. What's its type? JSON parse. Where's the JSON parse? I can see JSON. Yeah. So I just want to take a look at what's its type. Can I do something like maybe throw new error, something like this? Yeah, I can even do something like type of. Show me your type, brother. Show me your type. Okay, so that's the only thing I care right now. Just what's the type of that thing, so I can work with it. And where is the error method? Okay, so because of the stats I can't see shit, let's not log anything then. One more time. Oh, it didn't recompile it, god damn it. Okay, so that explains it. Alright, so let's try to do that one more time. It's still recompiling, it's in watch mode. Okay, come on, you can do that. Why does this take so much time to compile, bruh? Okay, finally. Alright. Okay, refresh, move. Finally. Okay, so what's the type? What's the type? Going deprecated object. Okay, so that's cool. Since we can see everything, maybe we don't even have to do it like that. So console log. Right, we can do something like this. Okay, refresh, boom. It's a buffer. It's a fucking buffer. I wonder if when I'm opening WSS, can I do binary? Oh, I can't. So that means when I get WS, what I have to do, I have to set binary type to array buffer in here. So is that what needs to be done? Because I don't want to be dealing with this like Node.js shit. I just want to have array buffers because that's what I get used to. Alright, so this is array buffer. Perfect. Thank you so much. That's perfect. Absolutely fucking perfect, mate. Absolutely fucking perfect. Okay. So what we have is, so this is event data. This is not what we want to do in here, that's for sure. But yeah. If event data, if event data is instance of array buffer, we're gonna do this usual thing. Otherwise, we're not gonna do anything. Otherwise, we're gonna mark it as a bogus amogus message. Bogus amogus, yeah. So essentially, we're gonna just copy paste this thing. I'm gonna increment the bogus amogus messages. So if it is array buffer, what we have to do now, we have to do new data view, event data, like this, and this is data. This is the view const, and there we go. So none of that it matters in here, right? None of that matters. We need to do the check, this kind of check. So that's how we check things. Player move, and this is I'm moving. Cool. If it is I'm moving, what we need to grab the ID. We need to grab the ID. So we kind of know our own ID. Well, we don't need ID in I'm moving, don't we? Yeah, okay. So I just realized that we don't need this kind of stuff. So it's only kind and okay, that's cool. So what we have to do in here is a common set moving mask player moving and we have to read that mask, common I'm moving struct, and this is moving, and I'm reading view at 0. Cool. So read the mask, I set the mask, and then I mark myself as moving. All right, everything's fine. Okay, so I think I managed to do that. So it's still not going to compile because I changed some stuff on the client, right? So because there's no ID anymore in there. So let's go here. So ID is not needed because we identify ourselves by the connection. So that means this entire thing should compile now. So ID, right? But did, oh yeah, so this is the second one. Okay, so now in the bots, I'm moving. We don't have I'm moving. But in the bots, by the way, yeah, so in the bots we have this kind of situation. And there's 2 places, yeah, so new direction and so on and so forth. But it should be relatively easy to just copy paste some stuff from the client, and that's about it. So let me see. It's more like a bot moving and bot WS. So this is that. And this is the second one. Okay, so and everything come out. We're done. We migrated completely to binary protocol. There's no JSON in here at all. There should be no JSON in here. So JSON, JSON parse. It's when you receive a string, but you will never receive a string, so it doesn't matter. So you can just like literally ignore this entire thing. You can just literally ignore. So when we, if it's a player moving, yeah, you'll never receive this thing, and we don't care. We're gonna just ignore this thing. Yeah, so we have to be a little bit careful in here, because when we are updating our own thing, JSON unaligned, JSON begun. Well, not really. So this one, this is where we handle player moving, and I think I can steal some stuff from here. Yeah, so this is the player moving, and I can just do it like that. So we're always receiving the binary data, so this is no-brainer in here. This is no-brainer. We don't need to even check stuff. Well, we'll still probably need to check it at some point, but not the way I do it right now. So if it is moving and the ID is equal to bot me ID, so yeah. ID equal bot me ID, what I need to do is instead of the player, I need to use bot, but there is also no view in here. Where is the view? View is here, and it's not even event, or is it? So it doesn't know what is data is not assignable to parameter because it doesn't know what it is. I see, because it's data one of these. We have to check, right? If event data instance of array buffer, we'll just do that. All right, so bot me moving, dot me moving, this one is not needed. All right, so any errors? I don't think I have any errors. Okay, so everything is compiled. There's no JSON. So no JSON in the bots. JSON in the client. There's no JSON in the client, and the JSON in the server. This is the wrong server. I need MTS JSON, there's no JSON in the server. Everything seems to be working. Everything seems to be working. At least compiling. Right, so we don't know if it's working, but at least it's compiling. Okay, so let's try to run the server. The server is fucked up, by the way. I need to bring back this. Yeah. I need to bring back the logging. All right, so here's what we have. All right, I can move around. Okay. I can bring the second player. Okay, so that's cool. So it's kind of like being weird. I don't know why. Oof. Oof, oof, oof. I don't know what's up with that. It's not particularly smooth, maybe because of the right. Okay, let's actually start the army of bots and see what is going on. Is it running? Okay, so here are the army of bots. So when I'm streaming, it's like significantly slower, so that is fine. So this is not what I want. Okay, so the tick is actually processed very fast, so it's within 60 FPS, so it's totally fine. So the amount of bytes sent per tick is very small. The amount of bytes received per tick is very small. Everything is super small. Even if we... Okay, so I think it's something because I'm streaming. Received per tick also went down, yeah. Received per tick, because we're now just sending like raw bytes. So I suppose we can work with that. Okay, I'm a little bit worried about strange lag. So let me try to go back to what we had before. So first I want to commit everything. Migrate, I'm moving to binary. Right, so let me also push all of that into the repo. Time to push the payload to your mom, yeah. So, but just a second, I want to go back to before the stream. All right, so, and just see if it's still lagging with the old code. Huh. It is. It kind of is. It kind of is. So this is probably because I'm streaming. So this is the old code. We can test that it is in fact old code. Yeah, so this is like a huge footprint of things. So that's definitely old code. All right, let's push that into your mom. I think it's already kind of pushed to, yeah, to your mom. All right, so she's ready. So let's sh your mom. So there's no TeamViews. So what is that? Multiplayer prototype. And what's the status? Clean FDX, git reset --hard. Yeah, so if you take a look at the log, migrate, I'm moving to binary. Okay. So everything's fine. So let's install everything. Your mom not there, unfortunately, yeah. So npm run build. And in the serve, I would like to maybe set, yeah. So let me do it like that. And 27. Still haven't fixed that one yet. Still haven't fixed that one yet. All right, so let me grab the IP. Right, so cut SSH config. So this is the IP. Let's go to here, 6969. It's not available. That's fine. Right, so let's do npm run server. All right, let's go. Okay, it's lagging like hell. So I think it's worse than it was before. Right, so you guys already joined, right? So let's actually see. So how do you feel? How does it feel laggy? It feels laggy. It's worse than last time. Okay, so there's something maybe. There's something with how we synchronize things. So yes, it is laggy. Okay, so I'm disconnecting everyone. Let me see. Random teleportations. Yeah. So that's understandable. Let's try to go back to what we had before. So stash. Okay, so a stash get check out this thing. So let me take a look at the log, indicate the client disconnected, right? Stash pop, and okay, so with diff npm run, not really watch but serve. All right, so we're using the old version. Okay, so how many people connected? Still lagging. Yeah, it is still lagging. All right, that's kind of weird. Similar lag. All right. I'm already streaming for 4 hours, so only lags on key press. Yeah, but this is old code, so the problem is not with the new code, that's for sure. The problem is not with the new code, so this is the old one. I don't remember being this lag this time. Maybe somebody's actually DDoSing us, I don't freaking know. So yeah, wait a second, let's actually try to run it one more time. So how many? Maybe somebody's literally DDoSing us. No, it's not that many people. Total messages sent. That's a lot of messages. That's a sus amount of messages, I would say. Well, I mean, no, it's sent. It's that we sent. In terms of messages we received, I guess it's fine. All right, so I'm already streaming for 4 hours. Right, so I'm gonna investigate that a little later, maybe tomorrow, and I'm gonna concatenate my conclusions to the VOD, right? So because obviously I would try to investigate that, but I'm already super tired because I've been refactoring this entire thing for 4 hours, right? So yeah, so I won't be able to do it right now, so maybe the next thing. All right, that's it for today. Thanks everyone for watching right now. Thank you for helping me to test all of that. And I see you all on the next recreation programming session with Mr. Azuzin. I love you. All right, this is the other day, and I think I figured out what exactly was the problem. I introduced a bug in the last commit I did on the stream. So it's so funny, right? So it worked fine, but then with the last commit, at the last moment, I introduced the stupid bug, and I was already too tired to actually figure it out what was the bug and stuff like that. So let me demonstrate you. So I'm gonna take a look at the latest commit I did, right? So the last commit I did on the stream is this one. So since then, I actually did a little bit of refactoring and stuff like that and figuring it out. So let's go to the latest one. So on your mom, I do in fact have the latest commit. Yeah, so this is the latest commit, and let's actually recompile just in case. But maybe it would be even better to just set the watch mode, if you know what I'm talking about, right? So run watch. So every time I do checkout, it actually recompiles everything, hopefully. Right, so let's actually do surf, and without anybody, right? So I'm not streaming live right now, just being alone on your mom. It's already having a stroke, right? As you can see, it's teleporting around. It's absolutely horrible, right? So it's like it's even being stuck, right? So yeah, okay, let's actually kill it. And the last commit that I did on the stream was this one, migrate I'm moving to binary. So what we have to do, we have to go to the commit before that and check it out. So let's actually take the commit hash and do checkout like this. So hopefully that did recompilation. I'm not sure if it did recompilation. Right, so but we can try to run it and see, because I would expect it to actually no, this, well, I mean, okay. So we need to do surf. Let's go. Let's refresh that. And as you can see, it's totally fine. So it's not teleporting around or anything. It's totally fine. So I introduced the bug in the last commit, in that specific commit. I can even go here, right? So let's actually grab the commit hash in here. So this is the first bad commit. Git checkout. We're gonna put it in here. So everything recompiled. That's actually nice. And let's actually serve the thing, right? So I'm going to refresh this entire stuff, and it's starting to teleport around. So this is the first commit where I introduced a bug. So what exactly happened in here? Let's actually draw like a time diagram. I'm not sure how these kind of diagrams are officially called, so let me know in the comments, right? So because I'm not a software developer, I don't know the terminology. So imagine that the time kind of goes down, right? So this is basically time. Maybe I'm gonna actually make it a little bit brighter. So, and you have two entities that are interacting with each other. The client, right? So this is the client and this is the server. So the way it worked before the bad commit. So the client would send the message I'm moving, right? So, and the way it would send it is probably something like this, right? So because there's a little bit of a latency in here, right? So a little bit of latency, the message is sort of like traveling to the server. And the message we have in here is I'm moving, right? So I'm moving. So the way it worked before the bug, I'm moving would just tell you that you started to move in a certain direction, right? So basically it would give you two parameters, whether you started to move in a certain direction or stopped moving in a certain direction. And based on these two parameters, the server would then update the moving mask of player, right? And, you know, figure out in what direction the player is actually moving. And then, only then, notify the client about the actual state of the player with the message player moving, right? Player moving. And that player moving message is going to contain X and Y, right? And also, I think that's it, right? So this is basically it would contain. So, and when the client sends I'm a moving message, it doesn't update its own state. It doesn't update its own state. It's only waiting for the player moving, right? And then as soon as it receives player moving with its own ID, only then it updates its state. And because of that, it actually synchronized very nicely, right? And it doesn't feel like it's teleporting around. So what happened? I changed the way I actually sent I'm moving. So now, instead of sending the direction and whether I started moving in a certain direction or not, I would update my moving mask and just send the entirety of the moving mask to the server, right? So the entirety of the moving mask to the server and continue using the, you know, the new moving mask. So, but what's interesting is that because of this latency, I'm having one state, but for the entirety of this time, server doesn't even know that I have this state, right? So it assumes completely different state. So in the entirety of this time, only then after this delta time of after this latency, it updates its state and starts updating the player with its own state. But because of this a little bit of a time some discrepancy was building up, and when everything is synced up, player starts to teleport. Right, so that's basically what happened. So this was a bad idea, right? So the fix is basically go back to this paradigm where the client doesn't update its state directly. It only updates it when it receives the player moving, right? And what it gives to the server, it gives to the server information, the direction, and whether it started moving that direction or stopped moving in that direction. So this approach actually worked fine, and I want to go back to that. So let's go ahead and do that. Let's go ahead and do that. So I'm gonna go to the latest commit, and let me see. So I'm gonna go into the definition of I'm a moving structure. So as you can see here, we have a moving mask, and that's about it. So what I want to do, I want to go back to direction, right? So it's going to be basically a value 0, 1, 2, or 3 that corresponds to the direction. So, and by the way, I changed the direction to be enumeration. I think I did that off screen. Yeah, so I did that off screen. And by the way, the player's state, right? So moving is now also a mask. So what I used to do, I used to have moving as a structure, right? So moving was an interface, and it would be a structure that had a key of the type direction, and it would be a boolean, right? So basically I would have like a bit mask as an object in JavaScript, right? Which is kind of silly. So I decided if I'm sending a mask over network, why not just also maintain the actual state of the player as the mask? It just makes everything easier, right? So because of that, I don't have to serialize and deserialize the mask. I can just grab the mask and just send it over the network. And if I need to check whether a player is moving in a certain direction, I can always do something like take the moving mask, shift to the right with the index of the direction, because direction right now is enumeration, right? So left is 0, right is 1, and so on and so forth, right? So basically move with the direction and basically take the lowest bit with 1, and there you go, you know whether you're moving in that direction or not. So it's totally fine. This is how I would do that in C. So I think it's a very good approach in here. So let's go back to I'm a moving definition, right? So I'm a moving. So now we have the direction, and since it's a number from 0 to 3, so I think we only need 1 byte in here, right? So we don't need to allocate too much in here. So first comes the kind of the message, right? So this is the kind, then the direction. And also we need information whether we started to move in that direction or not. So this is going to be start. And that's about it. So now we have a structure of 3 bytes, completely unaligned, but we don't really care. We don't really care. So let me align this entire thing like that. So I also actually added verifiers to the structure. So essentially now it has a verify method. So for example, in a client, if you do verify, yeah, there we go. So I used to first check the size of the structure and then look at the first byte and check that it's equal to a certain kind. Now I tucked all of that away to verify method, and it's actually very convenient in here, especially in a client where you have to sort of like chain these verifications, right? So you receive the message, we check, is that a join message? No. Okay. So is that a left message? No. Okay. Is that a moving message? It is a moving message, and everything is Gucci and everything is Tamaguchi. All right. So now we have the kind, the direction, the start, and the size, right? So everything seems to be working. So this is your mom, if I'm not mistaken, right? So I think I need to set up incremental compilation or watch mode on my local machine, right? So let's actually go to multiplayer prototype, and I'm gonna do just run watch. All right, so it should not compile, right? So because we changed the definition of this entire thing, yeah, there we go. So in common, yeah, return moving, we don't really have that stuff anymore. So now it's direction and start, right? So that's what we have. So let me enable fly check mode just to see what kind of errors we have in here. Fly check next error. There's no errors in here, surprisingly. Okay, so we're gonna assume that there's no errors in here. Let's go to let's start with the server, right? So let's start with the server and see what we have in here. So fly check next error. So let me update everything and enable fly check mode. So it looks like there's only one error in here. Okay, so we received a message from I'm moving, right? So that's what we did. And we used to actually send a moving mask. There's no moving mask here anymore. This one is actually kind of interesting. So I really like this idea. I think I also did it off screen. So to the player, I added new moving mask in here. Right. So the idea is that when you receive the messages and modify the mask, you're not modifying the actual mask of the player, you're modifying a copy. Right. So you receive a bunch of I'm a moving and stuff like that, and you modify the copy of the mask. And then when the time has come to process the tick, what you do, you check in. Is the player's moving mask not equal to the new one? And only then you notify everyone that the player has moved. So the idea is, what if you receive a bunch of I'm a moving events throughout the tick that canceled each other out? So by the time when you're processing the tick, the player's state didn't really change. In that case, like, there's no reason to even notify the rest of the players that something have changed. Right, so maybe you very, very quickly send I'm moving in different direction and then you stop moving, right? So, and by the beginning of the tick, by the beginning of processing the ticks, nothing changed at all. So we sort of like compressed all of these quick messages and didn't send anything. I think it's a good idea. I really like this idea. So let's actually go here. So we don't really have a mask in AMA moving structure anymore. So what we have instead is the direction and whether we started moving or not started or stopped moving. Right, so let's actually take a look. So we need to do start. The idea is going to be the following. So I'm going to read the start. And if you started moving, what I have to do, I have to basically set the corresponding bit in the new moving mask to 1. Right, so what is the corresponding moving bit? I think that bit is basically the direction, right? So I'm a moving direction, and maybe it would make sense to save this entire thing into a separate variable, even something like that. So I'm going to start. Const start Emacs. Are you fine? Okay. So it lagged a little bit. So start moving. How do I set that bit? Right. So essentially, let's imagine we have like a bit mask and stuff like that, and I need to set this specific bit. Right. So, and this is the direction, 2. Right. So because the actual indices of the bits are 0, 1, 2, 3. So I need to set the second bit in here to 1. So I will take 1, right? So I'm basically taking 1 and I'm gonna shift it to the left by the direction, like so. And afterwards I will just OR this entire thing with this thing, and I probably will assign it. I think I can do something like this even. Yeah, there we go. So, and if I do OR, it will just always set it to 1. Okay, that's cool. So when we stopped, we need to do the opposite thing, right? So in here, let's imagine that I need to set this specific bit to 0, right? So I need to set this specific bit to 0. All right, so I can basically construct the same kind of thing. I can do 1 to direction, and so that essentially means I will create this sort of mask. And what I can do now, I can use the, conjunction operation. So essentially, if I invert all of the bits in here like that, and then end it with the original mask, Emacs, don't have a stroke, please. Like, end it specifically. All of the corresponding bits where you had 1, they're gonna stay the same, but where you had 0, it will be set to 0. So that's how we sort of like set it to 0. So that's about it, I think. That's about it. We don't have to do anything anymore. So, and I think that's it. So there's no errors in the server. And now if I go to the client, right, so let's actually see what do we have in the client. So let's enable fly check mode and next. Oh, okay. So here, yeah, this one is interesting. As you can see, right away we're setting the moving beat, you know, for the current local player without even waiting for the confirmation from the server. This is the main problem in here. I should have not done that. I should have definitely not done that, but I've done that. It is what it is, and it isn't what it isn't. So let's not do that, right? Let's not do that at all. So in here, since it's a key down, we need to start moving. So that means here, what I have to do, I have to set 1, right, to start moving. And what's going to be the direction? So direction, we already kind of know the direction, so I just need to write it to the corresponding thing. So this is the direction, right, view, direction. There we go. So in the second error is probably here, so let's not do that. We can even copy paste this entire thing and replace the moving mask. We don't have to send it. So in here we have to set it to 0. There we go. So that should work. We have still a little bit of a problem with bots. Bots. So what was the line? The line was 72, 72. Okay. So okay. Yeah, all right. So this is rather interesting. So on the bot, when you do a turn, so how the bots work, right? So they basically move in a certain direction for a certain amount of time, and then when it's time for them to turn, we do the full stop, and then we send in what direction we're moving. So because because we switched to the mask, right, I thought that full stop is super easy to do. You just set it to 0 and you only send a new mask. It's not going to work like that. So what we have to do, I think, we have to go back into iterating through all of the directions and telling the server that, like, stop this specific direction. So since the direction is enumeration, I also employed like the C style trick. We still continue using C tricks, right? So now I have enumeration, and to know how many elements I have in enumeration, I use count in here, right? So that's basically what I'm doing here. So let's iterate to all the directions. So it's going to be from 0, direction less than, I think it's common message direction count, right? So direction count plus direction. And in here, what we can do, we can take the bot's moving mask, right? So then take the direction and take the lowest bit. And if we are moving in that direction, we need to tell the server that we don't move in that direction anymore. Okay, so how are we going to be doing all of that? So I'm going to do common a moving struct. So first of all, I have to write the kind into the view, and what's going to be the kind is going to be message kind moving, right? So moving. So this is the kind. Then we need to set the direction. Moving direction right view. The direction is this direction. As you can see, that's the current direction. And then since we're doing full stop, we always set start to false, right? So this is false now. There we go. So since we're going to be reusing view, I think I only need to sort of set it once to the corresponding kind, and we can just like change the direction and start. We can even probably do it like that, but I don't know. So I'm going to be reusing view down below, so I don't think it's a good idea. But anyway, so this is how we do full stop, right? So we iterate through all directions. If we move in that direction, we tell in the server we're not moving in that direction anymore, but we need to actually send this thing. So let me quickly do that, right? So now we're sending this and that thing. So now we picking the random direction, right? So picking the random direction, and we're actually setting ourselves to that direction. We should not do that anymore. We should receive that from the player moving, right? So because that's the confirmation that it received this entire thing. So and afterwards, we just need to notify the server that we're moving in that specific direction. I think I can do something like this. So we don't need to even set the kind anymore because we already set it to I'm moving like up there, so it's totally fine. So in here, we're moving to the new direction and we're actually moving. So start is 1, but for these things, it's 0. All right, I think that's basically it almost. So it's, oh yeah, okay. So we can just like reuse that view. Yeah, there we go. So that seems to be working. That seems to be working. So let me now see if it works at least locally, right? If it works at least locally. So I'm gonna run the server. So just serve. Locally teleporting is, you can't really feel the teleporting locally because it, like, the latency is actually too low, right? So it's not gonna tell us anything. So what we need to do, we need to bring that code to the server and see if it actually fixes anything or not. So let's do a committee and then fetch the latest changes, you know, on the server, on your mom. So I'm gonna do the following thing. So change, I don't know, the paradigm of AMA moving to what it was before, and maybe I need to take a look at the commit. What was the last bad commit? I think that was the last bad commit, but I want to take a look at the log. So yeah, that's the commit. Where is my commit message to before? So as far as I know, you don't really have to specify the entirety of the hash. You can just specify part of the hash and Git will recognize it properly. Change paradigm, I'm moving to what it was before this specific commit, and I'm going to push that right into the origin. So we're pushing that into the origin, and this is your mom. I can try to run your mom on the latest commit. So let me take a look at the git log. Okay, so let's check out main. Right, so this is git log, and I'm gonna run the serve. So this is before the fix that we just did, right? So this is before the fix, and as you can see, we're teleporting around. Okay, so let's actually close that and let's fetch the origin, right, and merge origin main. Okay, so and let's actually now serve and see if that fixes anything. It's not serve, it's serve. All right. Let's go. Let's refresh this entire thing, and it's fine. So that was literally the problem, right? That was literally the problem. I wish I could test that with the viewers, right? But unfortunately, it's offline currently, right? So, and I decided not to do a dedicated stream to this fix because it's very small. It's a very small fix. So you know what I'm thinking? It would be kind of cool to actually know what is this latency between the client and the server. Right, just some information for the player to estimate, right? So like why the game responds so slowly, and I think it's kind of easy to implement that. All right, so essentially we can introduce like a new kind of events, a new kind of command, which is a ping command. So essentially client sends a ping command to the server with a certain timestamp. Let's say it's going to be T1. Let me grab the tablet. Right. So the current time step T1. Then what the server does, right? So this is ping. And what the server does, it just sends that exact timestamp back to the client, right? So just send it back with the pong. Right. And the client will receive that at the time of T2. And since it knows, right, so what exactly it was sent, it can compute the delta time and maybe display that to the player, or maybe even use to correct the state of the player or something like that. I think this is something that games do all the time. And yeah, I think I finally got to the point where I do need to measure latency, right? So finally I'm learning something. Again, I've never done any network, like serious network game programming in my entire life. So I'm actually learning things, right? So, and I'm really happy actually that I discovered things. So let's go ahead and maybe introduce like a new command in here and even test how our serialization framework, allows us to do that easily, right? So we're testing maintainability of our framework essentially. So what we'll need to do, we'll need to define a new structure in here, right? So let's go ahead and do that. So what I need to do in here is ping struct, right? So this is going to be ping struct. We have to define it within a lambda. So we have to create an allocator, which we're going to use to allocate fields. So in here, we're definitely going to have a kind. And the other thing I need to have in here is probably some sort of a timestamp, right? So this is going to be timestamp. So in a timestamp, let's actually say that it's going to be uint32, right? So I think we're going to just simply send the performance now, right? So, and that's about it. So the responsibility of the server is going to be just send the whatever number the client sent back. Right, so that's what we're going to have in here. So then we're going to have the size, right, and the size is just the size of the allocator. So this is that. And then we also need to have a verification method, right? So this is going to be ping. Do we even have a ping? So we need to introduce two commands, ping and pong. Ping is something that the client is going to set to the server, and pong is something that the server will send to the client, right? So this is the first thing. So now we need to define pong, and pong, interestingly, is going to be, I think, the same. It's probably going to be the same, which kind of worries me. So I also need to return all of these things in here. So I need to return the kind, timestamp, the size of this entire thing, and the verify method, which will verify the structure. So, and here as well. So it's pretty much the same. So it's kind of weird. Can we just reuse the same structure for both ping and pong? The only difference between them is kind. But then, like, how are we going to verify that? So we have a verify method that is kind of bound to a specific kind, right? So you can't have two kinds in here, can you? You can't really have two kinds in here, unfortunately. That is a little bit sucky-wacky. What if we have two verify methods? So what if the structure is ping pong struct, and then you have method verify ping and then verify pong, right? So yeah, so the way you're gonna use that is essentially you're gonna have ping pong struct verify ping for some view, and if it's true, you do the ping stuff, and then you're gonna try to verify pong. And if it's true, you're gonna do the pong stuff, right? So why not actually? This is a very interesting paradigm. So essentially, if you have several messages that share the same structure, you can just have several verify methods, right? So depending on the kind and stuff like that. And it's pretty convenient, I think. It's pretty convenient. So verify ping, verify pong. All right. So that's what we have in here. Okay, so on the client, how often are we going to be sending the pings? How often we're going to be sending the pings? Maybe once in a while, right? So what is the FPS? Once a second. So do we have FPS? I don't freaking know. So ping, cool down, and let's say we're going to have like 60 ticks. Every 60 ticks, you have to send ping to the to the server, right? So here, when we're rendering everything, we check in whether we have a connection. WS is a WebSocket, right? So here we don't have a connection, we say disconnected. So here we do have a connection. So then we are updating the players, then blah 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 blah. So essentially here, what I want to do, I want to do cool down. So ping cool down, right? I'm going to subtract 1, and if at some point we reach the cooldown less or equal than 0, the time has come to send the ping, and also probably reset to 60. So it would be nice to maybe factor this out to a magical variable, right? So ping cooldown. Let's actually find, so this is going to be ping cooldown, and this one is going to be const. Ping cooldown is going to be 60. Why did you not put an underscore in here? All right. So in here, we need to allocate array buffer of the size. I'm a moving struct size, right? So, and we also want to slap data view on that, so we can modify specific fields and everything. So this is the view, const view. So in here, we just take, it's not a moving, what the fuck am I saying? It's a ping pong, bruv, ping pong. So ping pong, struct, I take the kind and I write into the view the kind that is common message kind ping, not pong, but ping, specifically explicitly saying that this structure is ping, not pong. Then I need to set the timestamp. So what's going to be the timestamp? I think it's just going to be performance now, right? So I'm taking the current timestamp and I'm setting it in here, and then I just send this over the socket. There we go. So we just send a ping to the server. That's pretty cool. All right, so then where do we receive the messages? So here we receive different messages, as you can see. So here's the player joined, player left, player moving, blah, blah, blah. And then here we are going to be specifically waiting for the pongs, right? So ping pong struct verify pong, right? So we're specifically looking for the pong. So this is the view of this thing. And in here, so what we can do, we can just extract the timestamp, right? So we're reading the timestamp from here. We're also taking the current thing, so performance now, and here is our ping, essentially. This is literally our ping. We can even save it to some sort of like a separate variable, I think. So where can, okay, so this is the place where we store the state of the player on the client, right? So this is going to be ping, is going to be originally 0, right? So, and here, okay, so once in a while, we're just like doing the ping, we receive the pong and we compute the ping, which we can then display somewhere, right? So for now, we can just display this entire thing in the logs just to see how it works out. Right, so, and on the server we also have to do a little bit of work, right? Server MTS. So, okay, so this is where we receive the messages from the clients. One of the messages we can now receive is a ping message, right? So let's quickly do that. So this can be else if common ping pong message verify specifically ping, because we can only receive ping from the client, like so. And what we do in here, and this is actually kind of cool. So what we can do, we can basically change its kind and send it back. Yeah, so that's actually kind of convenient. So we don't need to modify timestamp because we need to send the same timestamp to the client so it can measure the latency, right? So the only thing we do, we take the kind and we write into the kind message kind pong, right? So we change it to pong. So it's going to be pong, and this is common. And simply send it back. All right, WS send, is it really? Yeah, so it's just send view. So it's complaining about something. I'm not really sure what exactly. So message not king kind. Right, so in here we probably want to update some of this stuff. So we already updated that we received some new messages, right? So yeah, message counter received, right? So this is what we received. The only thing we have to do in here is probably update how many messages we sent, right? So this one is rather interesting. When I do WS send, right, so that's the things I'm updating. That's the things I'm updating. So bytes send counter and message set counter. But I have these counters only in the tick. So what I'm thinking is that so message byte send, I think I need to make them global and available in the input handler, because our code in the server is actually split into two parts, sort of like the input handler that receives the messages and then the tick handler. Right. So essentially, as we receive inputs, we just accumulate inputs and accumulate the discrepancy for the state. And then when the tick fires up, it looks at the discrepancy and then sends out the messages. So usually the code that receives the inputs never really sends out anything. But since we need to respond to the pings, I think this is something that we can do. Right. So, but because of that, I think... I think this is not particularly accurate, right? So because it doesn't, the ping will not include the entirety of the part where we processing the joined IDs, processing the left IDs, sending out all of these things and everything, blah, 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 blah. I feel like the ping has to be actually, processed in here somewhere. So, but how can we do that? So that means we should not send it right away. We rather should, you know, maybe have some sort of a structure in here, right? So join IDs, you know, ping IDs. So whoever needs to be pinged in here, And what's funny is that it has to be a map from a number, which is going to be the ID of the player, to the timestamp. Right, I think this is going to be a little bit more accurate, right? Because this approach will include the entirety of the processing of the state and everything, right? So I think it's kind of important. Right, so let's quickly do that. So essentially, we won't be able to do this kind of cool trick anymore. So let me see, ping IDs, right? So this is going to be ping IDs, and we just have to set the ID. So as far as I know, ID is the correct one. So this is the ID, and we just need to read the timestamp. So common ping pong struct timestamp read view. So this is read view, and that's about it, right? So that's about it. Okay, so that's pretty cool. Then now, in the place where we hand in the ticks, right? So we're first processing the joined IDs, right? So notifying everyone, then processing the left IDs, then updating the state of the players and everything. Right, so this is not, yeah, we're just notifying the movements and everything. And then updating and stuff like that. So the last thing is going to be probably pings, sending out pings. So let me see, ping IDs. I probably want to do something like for each for them. So first comes the value and then the key. Okay, so this one is going to be timestamp, and this is the player ID, right? So that's what we have in here. So for the player ID, I have to take the players and I have to get that player. So what's interesting is that maybe at some point we will not have any players, right? So maybe somebody sent a ping and then left. So that means there is a possibility of the player not being present in this table. So if the player not equal to undefined, right? So this may happen, right? A player may send a ping and leave. Yeah, so this is plausible. This is straight up plausible. Okay, so after that I need to do new. Maybe I can steal some code from the client. Right, so ping pong struct. So this is what I want to steal in here. There we go. So I'm allocating the size. I'm sending the kind to pong, and I'm sending back the timestamp. Right, so I'm sending back the timestamp, and I just then send WS, right, which is part of the player. So in here, finally, I have an opportunity to update the statistics of the counters correctly, right? So this is going to be byte, and this is message counter. All right, so and afterwards, I need to clean up ping IDs, and we're Gucci, I think we're Tamaguchi. So now it is more or less correct because it includes like everything in processing of the input of the server. All right, so does it compile? I'm not even sure what is that your mom or is that your mom? Okay, so this is your mom. Maybe I can change the you know, so this is your mom, right? So this is your mom, and this one is the streamer, right? So this is the streamer, right? At least I can distinguish them now. All right, so let me now see. I'm gonna do that locally, right? So I can move around. Let me do the DevTools, and in the DevTools, oh, there we go. So here's the ping. It's usually like 12 milliseconds. Look at that. Yo, that's pretty cool. Can I actually, you know, print that on the screen? I think I could print that on the screen. I think it's plausible. Let's go to the client MTS, and so here when we're disconnected, so we don't want to print anything when we're disconnected, somewhere here. Okay, so where is the text? So this is how we render the text, and So let's set the font to something smaller. Label is going to be something like ping, let's say ping ms, right? So, and in here, I suppose we can just do like a fraction of width, right? So let's just do fraction of width. Depending on the size, it's gonna be different. So this is your mom, this is streamer, and let's actually refresh this entire thing. And yeah, so can we just reduce the amount of digits in here? So JavaScript, JavaScript format floats. All right, so how do you format the floats? How to format floats in JavaScript? Okay. Two fixed. Jesus. All right. So two fixed. I wanna have 2 digits after the period. All right. So that seems to be all right. Look at that. I think the font is a little bit big. I really like how crappy the quality of the font is, right? So this is because I'm kind of stretching the canvas, and I could fix that, but this is the prototype, so that's how little I care about it, right? So it's a throwaway code, so nobody cares. Can I make like 18? All right, so because of that, I would like to maybe reduce that. So let's actually factor this out. Let's say that this is going to be some sort of a padding. Right, so this is padding, and let's reduce that a little bit. Let's reduce that. Okay, that's pretty cool. That's actually very cool. I wonder if I can, you know, send the bots and see if that actually reduces the ping, right? Okay, and just a little bit. It reduced the ping a little bit, but overall it feels nice. It feels okay. Okay, so let's actually close this thing, and let's commit that. I want to test that on your mom. Never gets old. So yeah, introduce ping, right? Ping pong commands, right? And I'm gonna push that right into your repo, right? Okay, so this is your mom. Let's actually fetch origin, merge origin main. Okay, so now if I do run serve, it's not server, it's serve. Right, let's take a look at the ping on your mom. All right, so yo, what the fuck? All right, so that's the 100 milliseconds. I mean, for 100 milliseconds for web developers is actually perfect. It's actually super fast. For the real-time gaming, it's kind of oof. But at least it feels all right, right? At least it feels all right. I wonder if on your mom, I also send out a bunch of bots. So let me actually try to do that. So multiplayer. So I'm gonna connect the bot through the local network, I suppose, from within your mom. I think it's gonna be fine. So I just want to have a bunch of players. All right. So no, it stays the same. So the ping roughly stays the same. Okay. Kind of interesting. So your mom is actually located in Germany, right? So, and I'm in Asia right now, so that's probably why it is so slow for me. So the next time I'll do live stream, right? So we'll test it for with people from Europe. So, and we'll figure out whether the ping is actually better for them. But I'll suspect that the ping is going to be better for them. It's just like I'm too far away from your mom. All right, so that's basically it. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Zozin. So the next step in this entire endeavor is finally integrating this networking code to the raycasting thingy, right? So again, we have this game that we've been developing, right? And I want you to make this game a multiplayer game. Right, so yeah, I finally figured out how to do networking, more or less. I'm still noob at it, but now I know a little bit more about it. So yeah, the next stream is going to be actually integrating this entire thing. But to integrate this entire thing, I also need some sort of like sprites for the player, right? So because now the player will be able to see each other, so how they're going to look to each other. So I'll probably need to spend some time like drawing the sprites. I'm not going to do anything super fancy, right? Something super simple. But yeah, that's the plan for the next stream. That's it for today. Thanks everyone, and I see you all on the next recreation programming session with Ahu Amistazozi. Love you all. Mwah.